When you have the perfect response in your head, but your fingers just can't keep up. We've all been there. Typing, deleting, retyping. Now I use whisper effect. I just think out loud and it creates perfect.
Hey guys, good evening, and welcome back again to your Unacademy NEET English channel. I hope all of you are doing great, having a good time. So let me know quickly in the chats if all of you can hear me, if I am perfectly audible, visible to every one of you. Let me know quickly in the chats, people. Let me know quickly in the chats, everyone. Just give me a second, let me fix certain things and we shall start, okay? Just give me a second. 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 I think the camera is a bit tilt. It's tilted. Let me just fix it. Just give me a second, guys. Is it fine now? Is it fine now? Yeah? All clear? All clear? So, guys, today we are going to kickstart your organic chemistry. Okay? We are going to kickstart your organic chemistry. Yes. And the first chapter, which we shall be doing in the today's session, what is that? That is your IUPAC nomenclature. What is going to be the duration of the session? The duration of the session is going to be not more than 3 hours. Not more than 3 hours. Yeah? All right. I think every single thing is perfect. Guys, am I perfectly audible, visible? Am I perfectly audible, visible? Just tell me that first of all in the chats. Am I perfectly audible, visible to every one of you? Just let me know that first. Don't worry, hydrocarbon also will be doing. We are starting the organic, so we'll be starting the organic from IUPAC only. Perfect? All right, people. All right. So today it's going to be complete basic lecture, right? I shall be completing your entire IUPAC nomenclature in just one session. That too in a very detailed form. Okay? That too in a very detailed format. And at the same time, we shall be solving the JEE level questions too in the today's session. So if the chemistry paper is coming tough also in the NEET 2026 examination, if the chemistry paper is similar to your NEET 2025 physics also, still you should be in a position to solve each and every question. Yeah? All right, so should we start then? Already? Should we start, people? Should we start? Everyone in the chats? Everyone in the chats, people? Notes I'll be sharing in the Telegram. Notes I will be sharing in the Telegram. If you're not the part of the Telegram channel yet, be the part of the Telegram channel. It is Wassim Bhat Chemistry Official. WASSIM BHAT Chemistry Official is the name of the Telegram channel on which I shall be sharing the handwritten notes of the today's session as well. Okay. Perfect. Okay, one question I'm going to ask you. How many of you have studied the IUPAC already? I just want to know. Say yes or no in the chats. Accordingly, I'll start the session. Have you studied the IUPAC nomenclature already? Say yes or no in the chats, everyone. Everyone. Okay, one thing I'm going to tell you. After watching this session, you will be in a position to solve each and every question which comes from your IUPAC nomenclature. Okay? All right? But I would want you guys to watch this session till the end. And this session is going to be short and precise only. Not more than 3 hours it's going to take. So let's start and finish this IUPAC nomenclature in an amazing way. All right? All right, people. So let's get going then. Let's get started. Let's get started. The IUPAC nomenclature. Let's get started with the IUPAC nomenclature from the topic that is alkanes. Okay? Alkanes. Well, my dear students, in order to name any organic compound as per IUPAC, if you want to give name to any organic compound as per your IUPAC, there are few rules which you have to follow. Just few rules you guys are supposed to follow. And what are those rules which you guys need to remember? Let me talk about those rules one by one first of all. Yeah? Let me talk about those rules one by one. Well, the first rule is, what is that? The first rule says that we are supposed to select the longest possible carbon chain. We are supposed to select, first of all, the longest possible carbon chain. Yeah? My dear students, as you can see, I have come up with these compounds here. So if you want to name this particular compound, the first thing is to select the longest possible carbon chain. Okay? Now tell me one thing. What do you think? Which one do you think is the longest possible carbon chain here? My dear students, if you see, this is your carbon number 1, this is 2, 3, 4, 5, 6, and 7. Can I say this particular chain over here? This is the longest possible carbon chain in this particular compound? Absolutely. It is the longest possible carbon chain in this particular compound. Yeah? Similarly, my dear students, look at this particular compound. If you want to name it, the first thing is you're supposed to select the longest possible carbon chain. Now. Can you select the longest possible carbon chain here in this compound? Absolutely, you can do that. See, this is your carbon number 1, for example. This is 2, this is 3, this is 4, 5, 6, 7, 8, 9. If you see, if I select this particular chain, it is going to be my longest possible carbon chain in this particular compound. Yeah? But dear students, look at this particular compound. If you want to name this compound as well, what you are supposed to do? You're supposed to select the longest possible carbon chain, right? Now see, which one do you think will be the longest possible carbon chain here? See, this is 1, carbon number 2, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11. So I must say, this is my longest possible carbon chain in this particular compound, right? So from now onwards, whenever you are supposed to name any organic compound, the first thing which you are supposed to do is, you are supposed to select the longest possible carbon chain. That is point number 1. Point number 2, my dear students. Point number 2. If more carbon chains are multiple in number, then we are supposed to select that particular chain which has maximum branches. What does that mean? What does that mean? Try to understand what that means. For example, look at this particular compound. Look at this particular compound, right? If you look at the possible carbon chain, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, right? So I'm selecting this as the longest possible carbon chain here. Now this is the same compound. This is the same compound. And in this particular compound, if I select this one, 1, 2, 3, 4, 5, 6, I can take this as the longest possible carbon chain as well. Absolutely. So if you look at this particular compound, my dear students, here I have selected this as the longest possible carbon chain. And in the same compound, the other way of selecting the longest possible carbon chain is like this. Now, which one should I consider as the parent chain? Which one should I consider as the parent chain? The one that is more branched, the one that has got more branches. If you look here, there is only one branch here. Okay. If you look at this particular chain, this is your one branch, this is your second branch. There are two branches here. So this is going to be my longest possible carbon chain, which I call as the parent chain in this particular compound. Right? Right, people? Similarly, look at this particular compound. Look at this particular compound. Now, let me try to do one thing. Let me select the longest possible carbon chain in this particular compound as well. See, this is carbon number 1, for example, 2, 3, 4, 5, 6, 7, 8. Right? So if I select this as the chain, right? So 8 carbon atoms in this particular chain. 8 carbon atoms. Perfect. Now, if I do one thing, 1, 2, 3, 4, 5, 6, 7, and 8. If I select this as the carbon chain, again, this particular carbon chain has got, this particular chain has got 8 carbon atoms. Right? This particular chain has got 8 carbon atoms. Even this particular chain has got 8 carbon atoms. Now, which one should I select as the parent chain? Which one should I select as the parent chain? The one that is more branched, the one that contains more branches, that is going to be my parent chain. Now, in this particular one, you can see this is your one branch, this is the second branch. But here in this particular compound, if this is your parent chain, then this is going to be branch number 1, this is going to be branch number 2, this is going to be branch number 3, and this is going to be branch number 4. So there are 4 branches here if you consider this as the parent chain. Correct? So this is going to be my parent chain in this particular compound. Am I clear to everyone? Is this particular point clear? Is this particular point clear, people? Quickly, let me know once in the chats. Everyone. Let me know quickly in the chats. Everyone. Yeah? So if in a compound you were able to select more than one chains, which contain equal number of carbon atoms, that particular chain you are going to consider as the parent chain that will be more branched. That is more branched. Right? Perfect. Perfect, guys. So rule number 1 was you're supposed to select the longest possible carbon chain. Now, if in a compound you could, for example, select 2 longest possible carbon chains, then which one you are going to consider as the parent chain? That particular one you are going to consider as a parent chain which has got more branches. That's all. Now, point number 2. Point number 2 is after selecting the longest possible carbon chain, you guys are going to give the numbering to the carbon atoms in the parent chain. That is rule number 2. You guys are going to give numbering to the carbon atoms in the parent chain. For example, this is the compound. I can do one thing. First of all, let me select the longest possible carbon chain. This is, for example, the longest possible carbon chain here in this compound. Now I have to do the numbering. See, there are 2 ways I can do the numbering here. I can do the numbering from left to right, or I can do the numbering from right to left. I can do the numbering from left to right, or I can do the numbering from right to left. When I do the numbering from left to right, this is going to be carbon number 1, this will be carbon number 2, this is 3, this is 4, and this is 5. Okay? And if I do the numbering from right to left, then this is going to be carbon number 1, this will be 2, this will be 3, this will be 4, this will be 5. So I've got 2 ways to do the numbering here, either from left to right or from right to left. Now, the rule tells us that the first locant should get the minimum number. If I'm doing the numbering from left to right, my dear students, I would say the first locant is getting number 4. First locant is getting number 4. If I'm doing the numbering from right to left, I would say first locant is getting number 2. And as per this particular rule, first locant should get the minimum number. First locant should get the minimum number. So minimum number is 2 over here. So my correct numbering will be from right to left. From right to left. Correct? Simple. Right, people? Now similarly, look at this particular one. Again, I've got two possible ways. First of all, let me select the longest possible carbon chain. I've selected the longest possible carbon chain here. Now I have to do the numbering of the carbon atoms in this parent chain. I've got two ways. I can either go from left to right or I can go from right to left. Now, my dear students, if I go from left to right, then it's going to be carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Right? This is left to right. And when I'm doing the numbering from left to right, the first locant, the first substituent is at carbon number 5. The first substituent is at carbon number 5. Now, if I do the numbering from right to left, then I'll be calling this as carbon number 1, this will be 2, this will be 3, this will be 4, this will be 5, this will be 6, and this will be 7. If I'm doing the numbering from right to left, the first substituent is getting number 3. First substituent is getting number 3. And you know, first locant should get the minimum number. So which one is the minimum number among the two? 5 or 3? 3 is minimum. So my correct numbering will be from right to left. My correct numbering will be from right to left. Yes, as simple as that. As simple as that. But dear students, look at this particular case. Again, let me first of all select the longest possible carbon chain. This is my longest possible carbon chain here. Now, I have to do the numbering. I've got two ways, either from left to right or from right to left. The first locant should get the minimum number. If I do the numbering from left to right, then this is going to be carbon number 1. This will be 2, 3, 4, 5, 6, and 7. The first substituent is at carbon number 4. So the first locant is getting number 4. If I do the numbering from right to left, then this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So the first substituent is at carbon number 2. So the first locant is getting number 2. Which one is lesser among the two? I'll say 2 is lesser among both of them. Right? Perfect. I believe I'm clear to everyone. Is every single thing clear till here? Is every single thing clear till here, people? Is every single thing clear? Yeah? So rule number 1, you have to select the longest possible carbon chain. Second point, if you could select more carbon chains, then which one do you consider as the parent chain? The one which has got more branches. Correct? Well, after selecting your main chain, after selecting your parent chain, you are supposed to give the numbering to the carbon atoms in the parent chain, right? And the first thing is, when you give the numbering, the first locant should get the minimum number. The first locant should get the minimum number, right? Now, my dear students, what if the first locant is same? What if the first locant is same? Then you have to go for the lowest sum rule. What does that mean? Have a look what I'm going to tell. First of all, here I'm selecting the longest possible carbon chain. Okay, this is my longest possible carbon chain. For example, here I'm doing the numbering from left to right. So this is carbon number 1, this is 2, 3, this is 4, this is 5, this is 6, and this is 7. Right? When I'm doing the numbering from left to right, the first substituent is at carbon number 2. The second substituent is at carbon number 3. Right? And the third substituent is at 6. Right? Perfect. Now, what if I do the numbering from right to left? When I'll be doing the numbering from right to left, then this is going to be carbon number 1, this is 2, this is 3, 4, 5, 6, and 7. So I would say first substituent is at second position, second substituent is at fifth position, and the third substituent is at sixth position. Okay. Now, do you see the first locant is same here in both the cases? Yes, the first locant is same. When the first locant is same, then you have to go for the lowest sum rule, my dear student. Lowest sum rule. Okay. lowest sum rule. What does that mean? Just add these numbers. 6 plus 3 is 9, 9 plus 2 is 11. Okay, do the sum here also. 6 plus 5 is 11, 11 plus 2 is 13. 11 plus 2 is 13. Lowest sum rule is followed. That means this is going to be the correct one. You are going to do the numbering from left to right. You are going to do the numbering from left to right. Am I clear with this? Yes. So if the first locant is same, then go for the lowest sum rule, right? Wherever the sum comes out to be least, that order is prioritized. As simple as that. Am I clear with this? Say yes or no in the chats quick. Quickly, people, everyone, is this clear? I believe this is clear to everyone. I believe this is clear to everyone. So this is the correct numbering order. This is the incorrect one. Yeah? Now guys, what if you are unable to decide as per the first locant rule, as per the lowest sum rule? What if you are unable to decide? What if you are unable to decide from first locant as well as the lowest sum rule? What if you are unable to decide from first locant and the lowest sum rule? At that point of time, go for the alphabetical order. At that point of time, go for the alphabetical order. What does that mean? Have a look. This is your main chain here. Okay. Let me do the numbering from left to right. Let me do the numbering from left to right. If I'm doing the numbering from left to right, this is your 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Okay. The first substituent is at carbon number 3. The second substituent is at 5. Okay. If I do the sum also, 5 plus 3 comes out to be 8. 5 plus 3 comes out to be 8. Now, for example, what if I do the numbering from right to left? What if I do the numbering from right to left? Right to left. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. The first locant is getting number 3. The second locant is getting number 5. So again, if you talk about the sum is coming out to be 8 only. So do you see one thing? First locant is same, as well as the sum is same. As well as the sum is same. So you are unable to decide from first locant as well as the sum. You are unable to decide from first locant as well as the sum. Now, right now I'll be using the alphabetical order. What does that mean? See guys, this is methyl group. This is CH3 group, methyl. This is your methyl group here. And if you look at this particular group, this is CH2, CH3. That means this is ethyl. This is ethyl. Methyl starts with M. Ethyl starts with E. In the alphabetical order, which comes first? Methyl or ethyl? Ethyl comes first. So ethyl should get the minimum number. So in which cases ethyl is getting the minimum number? In this particular scenario, ethyl is getting the minimum number. Right? So this is going to be my numbering order over here. Did you understand what I said? Did you understand what I said, people? Everyone in the chats quick. Did you understand what I said? Everyone. Again, let me repeat all the things, whatever I have told till now. First of all, we are supposed to select the longest possible carbon chain, right? We are supposed to select the longest possible carbon chain. Point number 1. Point number 2. If you could select 2 longest possible carbon chains in the compound, then that carbon chain will be the parent chain, which has got more number of branches. Once we select the parent chain, then we have to do the numbering to the carbon atoms. We have to give numbering to the carbon atoms, right? And how do we do the numbering to the carbon atoms? For that, rule number 1, first locant should get the minimum number. Rule number 2, if you are unable to decide from first locant, then go from lowest sum rule. If you are unable to decide from lowest sum rule also, then go for the alphabetical order. As simple as that. Yeah? I believe I'm clear to everyone. Now, this is something which I believe every one of you would be already knowing. Word root for 1 carbon atom, meth. Word root for 2 carbon atoms, eth. Word root for 3 carbon atoms, prop, but, pent, hex, hept, right? Oct, non, dec, undec, dodec, tridec, tetradec. Similarly, icos. Perfect. This is something which I believe every one of you would be already knowing, because this is something which we do in class 10th, right? Word root for carbon 1, word root for 2 carbon atoms, 3 carbon atoms, etc. Now, my dear students, whatever things I've told you till now, let me try to utilize those things and let me try to solve some basic questions with you first, so that you will master the concepts which we are done till now. Okay? Try to understand. What would be the name of this particular compound? First of all, select the longest possible carbon chain. This is the longest possible carbon chain. Now give the numbering. This is carbon number 1, this is 2, this is 3, this is 4. At carbon number 2, what do we have? At carbon number 2, we have got methyl. At carbon number 2, we have got methyl. So it's going to be 2 methyl, 4 carbon atoms in the main chain. So this is but. Everywhere there is a single bond, so it is ane. So it is 2 methyl butane. Simple. Yeah. Look at this one. Select the longest possible carbon chain. This is your longest possible carbon chain. Now do the numbering. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. At carbon number 2, we have got methyl. So it's going to be 2 methyl. It's going to be 6 carbon atoms in the main chain, so hex. Everywhere it's single bond, so I'm going to use ane. So 2 methyl. Yeah. I want you to write the names of all the compounds in the chats. I want the chat to be running today. Yes, there will be only one question asked from IUPAC nomenclature, but without IUPAC nomenclature, you won't be able to do the organic chemistry, right? So it forms the basis of everything. Yeah. Now, my dear students, look at this. First of all, this is your main chain, right? This is your main chain. Now, whether you want to do the numbering from left to right or right to left, one and the same thing. If you do the numbering from left to right, 1, 2, first locant is getting second position. If you are doing the numbering from right to left, 1, 2, first locant is getting the second position. The choice is all yours. So what is the name of this particular compound? Quickly in the chats. I'm looking at your chats. Quickly, everyone. Okay, let me do the numbering from here. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, and this is 6, right? 6 carbon atoms in the main chain. Now add carbon number 2 and 5. So 2, 5. First of all, between two numbers, we use comma. Between the number and the letter, we use dash. Between two numbers, we use comma. Between number and the letter, we use dash. So it's 2, 5. How many methyl groups? 2 methyl groups. So 2, 5, it's going to be dimethyl. 2, 5, dimethyl. Then 6 carbon atoms in the main chain. So it's going to be hex. Everywhere it's a single bond. Hexane. 2, 5, dimethyl hexane. Correct? Amazing. All right. What do you think about this one? What do you think about these three compounds? First of all, you have to select the longest possible carbon chain. Now, which one is the longest possible carbon chain here? If you select this as the longest possible carbon chain, so how many carbon atoms will be there? 1, 2, 3, 4, 5, 6. Okay. If I select this one, how many will be there? 1, 2, 3, 4, 5, 6. So there are two possibilities of selecting the longest possible carbon chain, but I would be selecting that one as the parent chain, which has got more substituents attached, right? So let me call this as carbon number 1. This is 2, this is 3, this is 4, this is 5, and this is 6. Now at carbon number 2, we have got methyl. At carbon number 4, we have got ethyl. Ethyl starts with E. Methyl starts with M. E comes first in the alphabetical order. So I'll prioritize ethyl first. So I'll be writing first of all 4-ethyl. 2-methyl. 4-ethyl, 2-methyl. In the main chain, there are 6 carbon atoms. So it's going to be hex. Everywhere there's a single bond. So it's ane. So 4-ethyl, 2-methyl, hexane. Correct? Right? So basically, at carbon number 4, we had ethyl. At carbon number 2, we have methyl. Ethyl starts with E. Methyl starts with M. E comes first. Then comes your M. So I'll prioritize ethyl first. So that's why I wrote ethyl first. Simple. Look at this one, guys. Look at this one. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. Perfect. Now, at carbon number 2, you have got methyl. At carbon number 3, you have got methyl. At carbon number 4, you have got ethyl. Ethyl starts with E. Methyl starts with M. I'm going to prioritize ethyl first because E comes first, then comes your M. Right? So, it's going to be 4-ethyl. 2, 3. 4-ethyl, 2, 3. Dimethyl. 2, 3. dimethyl. 7 carbon atoms in the main chain, so it's hept. Everywhere it's single bond, so it's ane. Perfect. So this is going to be the name. Look at this one, guys. Tell me the name of this particular compound quickly. I'm looking at your chats only. Quickly. What do you think will be the name of this particular compound? Everyone. Everyone. Now, for example, this carbon number 2, 1, 2, this is 3, this is 4, this is 5, and this is 6. Right? So at carbon number 3, ethyl group. At carbon number 4, again ethyl group. So it's going to be 3, 4, 3, 4 diethyl. 3, 4 diethyl. Then 6 carbon atoms in the main chain. So it's hex. Everywhere it's single bond. So it's hexane. So 3, 4 diethyl hexane is the name. Why you are saying dimethyl? This is CH2CH3. CH2CH3 means C2H5, ethyl. This is CH2, this is CH3, which is basically ethyl. Right? Perfect. So it's 3, 4 diethyl hexane. All right. Now, my dear students, how do we name a complex substituent? How do we name a complex substituent? Till now, we were only talking about the simple substituents like methyl, like ethyl, propyl, etc. Right? How do we name the complex substituents? Have a look. First of all, for example, this is your main chain. Let me call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. This is your main chain. And in the main chain, there's a branch. And in the branch, there is one more branch. In the branch, there is one more branch. So this is a complex substituent. It's a complex substituent. How do we name a complex substituent? First of all, at carbon number 4, what do we have? We have got a complex substituent. At carbon number 4, we have got complex substituent. Now, in complex substituent, again, you have to do the numbering separately. In complex substituent, again, you have to do the numbering separately. Let me call this as carbon number 1. Let me call this as carbon number 2. Right? In the complex substituent, at carbon number 4, you have got a complex substituent. Now, in the complex substituent, at 1, you have got methyl, and this is ethyl. So it's going to be 1 methyl ethyl. It's going to be 1 methyl, and this is ethyl, right? 1 methyl ethyl. Then it's going to be 7 carbon atoms in the main chain, so it's hept. Everywhere it's a single bond, so it's heptane. So 4 1 methyl ethyl, 4 1 methyl ethyl, heptane is the name of this particular compound. Did you understand? Did you understand? I want the chats to be running continuously. I want you guys to name all these compounds. Yeah? All right. Now, my dear students, what if there are two same complex substituents attached? What if there are two same complex substituents attached? See, this is complex substituent, even this is complex substituent, right? Your methyl ethyl. So, two same complex substituents are attached. If two same complex substituents are attached, then we use the term bis, or two same complex substituents. If there are three same complex substituents then it's going to be tris. If there are two same complex substituents, bis. If there are three same complex substituents, tris. If there are 4 same complex substituents, then you call this as tetrakis. Similarly, pentakis, etc. Okay? So, my dear students, first of all, do the numbering. Let's call this as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? So, first of all, at 4 and 5, you have got two same complex substituents. If there are two same complex substituents, I'll be using the term bis. I'll be using the term bis, right? 4, 5 bis. Now, 4, 5 bis. Now, what is going to happen? What's going to be the name of it? Quickly in the chats. 4, 5 bis. Now, talk about one complex substituent and do its numbering separately. So, this 1, 2. So, this is 1 methyl ethyl, right? So, this is 1 methyl ethyl. 1 methyl ethyl. Then talk about the main chain, 9 carbon atoms. So, none. Everywhere single bond. So, it's ane. Perfect. So, bis represents See, at carbon number 4 and 5, there are two complex substituents, right? Two same complex substituents, I would say. Right? One methyl ethyl. This is the name of the first complex substituent. There are two complex substituents like this. That's why I've used the bis term. And in the main chain, there are 9 carbon atoms, so none. Everywhere there's single bond, so it's 8. Perfect? I believe this is clear. I believe this is clear. Now, my dear students, let's see how alkenes are named. Let's see how alkenes are named. Okay, let's see how alkenes are named. Well, in order to name an alkene, there are two things which I would want you guys to remember. Just two things. In order to name any alkene, two things I want you guys to remember. First one, double bonded carbon, it should receive the lowest number. It should receive the lowest number. Double bonded carbon must receive the lowest number. Point number one. Point number two, maximum multiple bonds are to be included in the main chain. Maximum multiple bonds are to be included in the main chain. What does it mean? Try to understand. First of all, this is a very simple one. As I told you, double bond should receive the minimum number. So let me start the numbering from here. 1, 2, this is 3, this is 4, this is 5, this is 6, this is 7. So it's first of all hept. It is first of all hept. At carbon number 2, there is a double bond. So it's ene. It's hept to ene. Correct? Now there are two double bonds here. There are two double bonds. As I told you, maximum multiple bonds are to be included in the main chain. That means both these bonds should be the part of the main chain. Both these bonds should be the part of the main chain. Both these bonds should be the part of the main chain. Now, let me call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Correct? So first of all, at carbon number 3, what do we have? At carbon number 3, we have got methyl. At carbon number 3, we have got methyl. How many carbon atoms do you see? 7. So I'll be writing hept. But I won't be writing hept here. I will be writing hepta here. Hepta. When there are two double bonds in the main chain. When there is more than one double bond in the main chain. Or if there is more than one triple bond in the main chain. If there is more than one double bond in the main chain or more than one triple bond in the main chain, we use the term a here after the word root. So it's not hept, it's hepta. It's not hept, it's going to be hepta. Correct? It's going to be hepta. Now, at carbon number 1 and at carbon number 5, you have got two double bonds. It's diene. It is diene. Correct? 3-methyl, hepta, 1,5, diene is going to be the name of the compound. I hope you are remembering the things which I'm telling you. If there are 2 or 3 or 4 or 5 or 6 double bonds in the parent chain, then after the word root, A is used. Hepta, hexa, penta. Right? And similarly, leave the double bonds aside. If there are 2 triple bonds in the main chain, 3 triple bonds in the main chain, 4 triple bonds in the main chain, then again this A letter is used. Yeah? Alright, what should be the name of this one? Well, this is carbon number 1, this is 2, this is 3, this is 4, this is 5. This is 5. So it's going to be, first of all, 5 carbon atoms means pent. So should I use pent or penta? There are 2 double bonds in the main chain. I'll be using penta, right? At carbon number 1 and carbon number 3, it's 1, 3. That is going to be diene. It's going to be diene. Yes? Perfectly done, guys. Perfectly done. I hope you are understanding all this properly. Tell me the name of this one. This is your 1, this is 2, this is 3, this is 4, this is 5, 6 and 7. So first of all, it's going to be hept or hepta. It's going to be hepta. It's going to be hepta, right? Because there are 3 double bonds in the main chain. Hepta. Now, at carbon number 1, at carbon number 3, and at carbon number 5, there is a triple bond. So hepta 1, 3, 5, triene. Right? Triene. Correct? What about this one? What about this one? First of all, multiple pi bonds should be, multiple bonds should be included in the main chain. So there are two pi bonds there, and both the pi bonds should be the part of the main chain. That has to be the priority. Both the pi bonds should be the part of the main chain. Okay? Both the pi bonds should be the part of the main chain. So this is going to be my main chain. This is going to be my main chain. Now, if you want to start the numbering from top, 1, 2, 3. If you start the numbering from bottom, 1, 2, 3. So one and the same thing. So let's call this carbon number 1, 2, this is 3, this is 4, this is 5. Now at carbon number 3, we have got 1, 2, 3. We have got propyl group. At carbon number 3, if you see this, it's a propyl group. So at carbon number 3, we have got propyl. We have got propyl. Now 5 carbon atoms in the main chain. So it's pent. It is pent. Now 2 double bonds in the main chain. So it's penta. Now at carbon number 1 and carbon number 4, 1, 4, there is a double bond. So it's diene. Correct? Now talk about this one. Talk about this one. Both the double bonds should be the part of the main chain. That's the priority. Both the double bonds should be the part of the main chain. Now, so this is going to be your main chain. This is going to be your parent chain. This is going to be your parent chain. Now from where should I do the numbering? If I do the numbering from top to bottom, this is 1, this is 2, this is 3. Then at carbon number 3, you have got methyl, and carbon number 4, you have got ethyl. Okay? If I do the numbering from bottom to top, this is 1, 2, 3. Then at carbon number 3, you have got ethyl, carbon number 4, you have got methyl. Now ethyl starts with E, methyl starts with M. Which one to prioritize alphabetically? E, we have to prioritize. So ethyl should get the minimum number. If ethyl has to get the minimum number, then do the numbering from here. 1, 2, 3, this is 4, this is 5, this is 6. So at carbon number 3, we have got ethyl. At carbon number 3, we have got ethyl. At carbon number 4, we have got methyl. We have got methyl. In the main chain, there are 6 carbon atoms, so it's hex. Is it just going to be hex or it's going to be hexa? There are 2 double bonds here in the main chain, so it's going to be hexa. Now at carbon number 1 and carbon number 5, there are 2 double bonds, so it's going to be diene. Did you understand what I said? Yes. It is 3 ethyl, 4 methyl, hexa 1,5 diene. Not hexa 1,6, it's 1,5. It's hexa 1,5. Alright, people, I believe this is clear. And if this is clear, then let's talk about alkynes. We are done with alkanes. We are done with alkenes. Now it is the time to discuss alkynes first, right? Then we are going to introduce functional groups in them also. Just wait, slowly, we'll be scaling the things up. Let's discuss the alkynes. My dear students, in case of alkynes, again same rules. Again same rules. Triple bond should get the minimum number. Triple bond should get the minimum number. If there are 2 triple bonds in the main chain, they should be, if there are 2 triple bonds in the compound, they should be the part of the main chain. They should be the part of the main chain, right? Now have a look. There's a triple bond here. This is carbon number 1, this is 2, this is 3, this is 4. So it's going to be, first of all, but, right? But, 1, ine. Simple. Yeah, it's going to be but 1 ine. What about this one? What about this one? Triple bond should get the minimum number. So calling this carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So first of all, it's going to be hept. Is it just going to be hept or it's going to be hepta? There are 2 triple bonds in the main chain. So it's hepta. Now at carbon number 2 and carbon number 4, it's 2, 4, it's diene. Hepta, 2, 4, diene. Not ene, it's ine, because these are triple bonds. They're triple bonds. Right? Look at this one. Look at this one. Now, there are 2 triple bonds. Both of them should be the part of the main chain. So calling this 1, this is 2, this is 3, this is 4, this is 5, this is 6, and this is 7. So at carbon number 3, we have got ethyl. CH2CH3, this is ethyl. So at carbon number 3, we have got ethyl. At carbon number 3, ethyl. Now 7 carbon atoms in the main chain. So it's hept. Is it just going to be hept or hepta? There are 2 triple bonds. So it's going to be hepta. Now at 1 and 6, at 1, 6, it's going to be diene. Right? It's going to be diene. Yes, these are triple bonds. Am I clear, guys? I believe it's clear to everyone. I believe it's clear to everyone. Okay. Now, my dear students, this is a compound which contains triple bond as well as double bond. Nothing you have to do. First locant should get the minimum number. If you are unable to decide on the basis of locant, then go for sum rule, lowest sum rule. If you are unable to decide on the basis of sum rule, then go for alphabetical order. Let's try to analyze this. First of all, I can do the numbering from left to right, or I can do the numbering from right to left. If I do the numbering from left to right, then the first locant is getting number 1, right? If I do from right to left, then the first locant will be getting number 2, 1, 2, correct? Which one to prioritize? Left to right? 1, this is 2, this is 3, this is 4, this is 5, correct? So first of all, it's going to be pent. It's going to be pent. You're not going to write penta here because one is double bond, one is triple bond. If both of them were double bonds or both of them were triple bonds, then you are supposed to write penta. But here you'll write pent. Okay. Now, this is ene, this is ein. This is ene, this is ein. Ene starts with E. Ein starts with Y. Which one comes alphabetically first? E or Y? E. So I'll prioritize this first. So it's pent, 1 ene, pent, 1 ene, and it's going to be 3 ein. 3 ein. Now, after this E, vowel sound is starting. After this E, vowel sound is starting. So you have to drop this E here. You have to drop this E. Right? You have to drop this E. Perfect. Now look at this one. Multiple pi bonds should be the part of the main chain. Multiple bonds are to be the part of the main chain. Now tell me the answer of this particular question. Tell me the answer of this particular question. If I do the numbering from here, 1, 2, 3, the substituent is getting the third number. 1, 2, 3, again third number. It does not matter. Now, if I start from bottom, then this carbon is getting number 1. If I start from top, then this is getting number 1. This is ein. This is ene. This is ein. This is ene. Ene starts with E. Ein starts with Y. E comes alphabetically first. So I'll be calling this as carbon number 1. This is 2. This is 3. This is 4. This is 5. Did you understand? So at carbon number 3, 1, 2, 3, 4. At carbon number 3, you have got butyl. At carbon number 3, you have got butyl. Now, in the main chain, 5 carbon atoms. So it's pent. It's going to be pent. Is it going to be pent or penta? It's just going to be pent. Because one is double bond, one is triple bond. If both of them were triple, then penta. If both of them were double, then penta. But here, one double, one triple. So pent. Okay. Now, this is ene, this is ein. So I'll prioritize E first. So it's pent, 1 ene, pent, 1 ene, and 4 ein. Right? And after this E, vowel sound has started. So drop this E here. Drop this here. I hope this is clear to everyone. Okay? I hope this is clear to everyone. And if this is clear, tell me the answer of this particular question, guys. Tell me the answer of this particular question. Again, it's simple. 1, 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8. Why I did from left to right? Simple. First locant. First locant should get the minimum. So first locant is getting number 1. If I started from here, then this was 1, this was 2. Then the first locant was getting number 2. Then the first locant was getting number 2. If I do from right to left. Right? First locant should get the minimum number. So what should be the name of this particular compound? It's first of all oct. It's first of all oct. Is it going to be octa? No, it's not going to be octa. Now this is ein, this is ene. E comes first, then comes Y. So it's oct 7 ene, and 1 ein. After E, vowel sound is starting, so drop the C. Sir, tu que droza? Broza iti. Irmazi. All right, what do you think about this one, guys? What do you think about this one? Quick. From where should I do the numbering? From left to right or right to left? What do you think? What do you think? See, this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. If I do the numbering from left to right, then first locant is at first, number 1. Second, number 3. Third, number 6. This is left to right numbering. Left to right. If I do the numbering from right to left, this is 1, this is 2, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6, this is 7. Then the first locant is at number 1. Second is at number 4, right? Third is at number 6. Perfect. So first locant is same at both the ones. Now do the sum. 6, 3, 9, 9 plus 1, 10. 6, 4, 10 plus 1, 11. Lowest sum favors here. So I'll do the numbering from left to right. Now after doing the numbering from left to right, what do you think will be the name of this particular compound? So 7 carbon atoms. So it's going to be first of all hept. Right? Sir. Someone is saying sir. Above one answer is oct 16. Oct? What did I write? Put 7? Okay. Oct 6. Okay. Now clear? Okay, so what do you think will be the name of this particular compound? Quickly. So first of all, it's going to be hept. Is it going to be hept or hepta? There are 2 pi bonds. I'll write hepta. I'm going to write hepta, right? Now, ene and yne. Ene starts with E, yne starts with Y. So I'll prioritize ene first. So it's going to be 1, 3. It's going to be 1, 3. Diene. 1, 3 diene. And then it's going to be 6 yne. 6 yne. After E, vowel sound is starting. So drop the C. Clear? Perfect. I believe all of this is clear. Right, people? Am I clear with this? Quickly in the chats? Everyone? Now let's talk about cyclic compounds. My dear students, you must be knowing, in case of cyclic compounds, what do we use? We use the term cyclo first. For example, look at this one. 1, 2, 3, 3 carbon atoms. So it's basically propane, but it's cyclic. So I'll be calling this a cyclopropane. This one I'll be calling as simply cyclobutane, 4 carbon atom. Cyclobutane. Now here do the numbering. Let's call this as 1, this is 2, this is 3, this is 4, this is 5. So it's going to be 1, 2 dimethyl. 1, 2, 1, 2 dimethyl. 1, 2 dimethyl. Then it's going to be cyclo. 5 carbon atoms. It's going to be pent. Everywhere single bond. So it's going to be ane. Right? 1, 2 dimethyl cyclopentane. Clear? Clear, guys? Look at this one. There's a pi bond here. So start the numbering from the pi bond. Let's see, this is 1, this is 2, this is 3, this is 4, this is 5. So first of all, I'll write cyclo. Then it's going to be pent. Right? At carbon number 1, it is a double bond. So pent 1 ene. Now again, 1, 2, 3, 4, 5 and 6. First of all, it's going to be 1, 2 dimethyl. 1, 2 dimethyl. Then it's going to be cyclo. 6 carbon atoms, so hex. Right? At carbon number 1, there's a double bond. So it's 1 ene. 1, 2 dimethyl cyclohex 1 ene. Look at this one. Guys. Look at this one. Should I start numbering from here? Or should I start numbering from here? Which one to prioritize? Here you have got ethyl group. CH2, CH3, ethyl. Here you have got methyl. Ethyl starts with E, methyl starts with M. So let me prioritize this one. 1, 2, 3, and 4. Perfect. Now ethyl starts with E, methyl starts with M. So ethyl comes first in the alphabetical order. So it's first of all 1 ethyl. Then it's 2 methyl. 1 ethyl, 2 methyl. Then it's going to be cyclo. 4 carbon atoms in the main chain. So it's going to be but. Right? Double bond at carbon number 1. So it's 1 ene. But 1 ene. Clear? Is it clear, guys? I believe this is clear to everyone. And if this is clear to everyone, let's give the names to these compounds as well. I'm calling this is carbon number 1, this is 2, this is 3. So it's going to be 1, 2 dimethyl, 1, 2 dimethyl. Then it's going to be cyclo, P-R-O-P, prop. At carbon number 1, there's a double bond, so it's ene. Right? Talk about this one. For example, start the numbering from here. 1, 2, 3, 4, 5, 6. So it's going to be cyclo, hex. Should I write hex or hexa? There are 2 double bonds in the main chain, right? So it's going to be hexa, right? Then it's going to be at carbon number 1 and 4. 1, 4, it's going to be diene. 1, 4 diene, right? Talk about this particular one. Which one should I consider the main chain? This one or this one? This linear one or the cyclic one? Which one should I consider the main chain, the parent chain? Quickly, can you tell me in the chats? See, first of all, if I consider this as the main chain, then 1, 2, 3, 4, 5 carbon atoms. If I consider this as the main chain, 1, 2, 3, 4 carbon atoms. This one has got more carbon atoms, so let me call this as the parent chain. 1, 2, 3, 4, 5. Now it's going to be at carbon number 2. What do we have? At carbon number 2, we have got a substituent. Right? At carbon number 2, we have got a substituent. So I'll say it's going to be 2. This is cyclobutyl. This is cyclobutyl. 4 carbon atoms here. Then it's going to be simple. Pent. Everywhere there is single bond. It's going to be pentane. 2 cyclobutyl pentane. Yeah? Am I clear? Am I clear, people? Say yes or no in the chats. All right. Now this is cyclic. Even this is cyclic. Now which one contains more number of carbon atoms? 1, 2, 3, 4, 5, 6. 1, 2, 3. So this one contains more carbon atoms. So this is my priority. This is my parent chain. So carbon number 1, let's say this is 2, this is 3, this is 4, this is 5, this is 6. Now at carbon number 1, what do you see? At carbon number 1, this is propyl. Which propyl? Cyclopropyl. At carbon number 1, we have got cyclopropyl. Cyclopropyl. Then it's going to be cyclohexane. It's going to be cyclohexane. Simple. Right? Now, should I consider this as the main chain or this as the main chain? Now check the number of carbon atoms. 1, 2, 3. 1, 2, 3, 4. This has more number of carbon atoms, so this is the main chain. 1, 2, 3, 4. Now at carbon number 1, we have got a complex substituent. At carbon number 1, we have got a complex substituent first. At carbon number 1, we have got a complex substituent. So do the numbering separately. 1, 2. So it's going to be 1 methyl ethyl. So it's going to be 1 methyl ethyl. 1 methyl ethyl. And it's simply going to be your cyclobutane. Cyclobutane. Did you understand this as well? I'm going to add the functional groups in some time. Just wait. Just wait. We have to discuss a lot of things. Just wait. I'm just starting. I'm just starting. Functional groups will be added in some time. Before doing the functional groups, you have to discuss spiro compounds and bicyclo compounds. Then I'll jump into the functional. Okay? Now, guys, after discussing the cyclo compounds a bit, now let's try to discuss your spiro compounds first of all. So first of all, what are spiro compounds? Whenever you see such kind of the compound, 2 rings having 1 atom in carbon. Sorry, 2 rings having 1 atom in common. 2 rings having 1 atom in common. You call this particular compound as the spiro compound. And this particular carbon is called as spirocarbon. This particular carbon is called as spirocarbon. Whenever you see 2 rings attached with the help of 1 carbon atom, right? You call this particular compound as the spiro compound, and this particular carbon is called as spirocarbon. Now, how do we name such kind of the compounds? How do we name such kind of the compounds? See, guys, let me show you exactly how do we name such kind of compounds. Let me show you how do we name such kind of the compounds. First of all, it is spiro. 2 rings attached with the help of 1 carbon atom. 2 rings attached with the help of 1 carbon atom. So first of all, write spiro. Write spiro in both of them. After writing spiro, what do we have to write? First of all, I will have to do the numbering. Now, in which ring should I start the numbering? I will start the numbering in that particular ring that contains lesser number of carbon. So which ring contains lesser number of carbon atoms? This ring contains lesser number of carbon atoms. So I'll do the numbering in this ring first. Not from the spirocarbon though. Not from the spirocarbon. The carbon adjacent to spiro. This is carbon number 1. This is 2. Let's call this as 3. Let's call this as 4, 5, 6, and 7. Right? Clear till here? Okay. Now, in this smaller ring, apart from the spirocarbon, how many carbons do you see? 2 carbons. In this bigger sized ring, apart from the spirocarbon, how many carbons do you see? 1, 2, 3, 4. 2, 4. 2, 4. How many carbon atoms total? 7. So it's going to be hept. Everywhere there is single bond. So it's ane. Pyro, 2, 4, heptane. Okay? Right? Similarly, my dear students, look at this one. Again, it's a spiro compound. Okay? First of all, do the numbering. Should we start the numbering from the spirocarbon? No, we are not going to start the numbering from the spirocarbon. We'll start the numbering from the carbon which is adjacent to spiro. Right? And that too in that ring which contains lesser number of carbon. So which ring among the two contains lesser number of carbon atoms? This one. So let me call this as carbon number 1, this is 2, this is 3, this is 4. Let's call this as 5, 6, 7, and 8. So spiro. You have mentioned already the term spiro. Now in the smaller sized ring, apart from the spirocarbon, how many carbon atoms are there? 1, 2, 3. In the larger sized ring, apart from the spirocarbon, how many carbon atoms are there? 1, 2, 3, 4. So 3, 4. Right? So in total, how many carbon atoms do you see? 8. So it's oct. Everywhere it's single bond. So it's octane. Am I clear with this, everybody? Am I clear with this, everybody? Am I clear with this? Yeah? Okay, let's take few more cases. 2 rings fused with the help of a carbon. 2 rings fused with the help of a carbon. Right? Attached with the help of carbon. So again, these are spiro compounds. Now guys, have a look. Which ring should I prioritize for numbering? That ring that contains the lesser number of carbon atoms. 1, 2, 3. 1, 2, 3, 4. So this one I have to prioritize. Following this is 1, this is 2, this is 3, this is 4, this is for example 5, this is 6, this is 7, this is 8. So first of all, I'll be writing spiro. Right? Now this particular ring, which contains minimum number of carbon atoms. 1, 2, 3. 3 carbon atoms, comma. 1, 2, 3, 4. 4 carbon atoms. In total, 8 carbon atoms, so oct, right? At carbon number 6, there is a double bond, so it's ene. Oct, 16. Perfect. Now look at this particular one. Again, I'll be starting the numbering from that particular ring which contains lesser number of carbon. 1, 2, 3. 1, 2, 3, 4. So this one. 1, this is 2, this is 3, this is 4. Now, should I call this as 5 or this is 5? This will be 5 because this substituted. 5, 6, 7, and 8. So first of all, it's going to be 5, 6 dimethyl. 5, 6 dimethyl. First of all, it's going to be 5, 6 dimethyl. Then it's spiro. It's going to be spiro, right? Now, in this particular ring, smaller one, 1, 2, 3, 3 carbon atoms. In the larger one, 1, 2, 3, 4, 4 carbon atoms. So spiro 3, 4, right? Total, there are 8 carbon atoms. So it's oct. Everywhere, there is a single bond. So it's ane, right? So this is going to be the name of it. Am I clear with this? Am I clear with this, people? Everyone? I'll give you the dinner break at 9:30. Don't worry. 9:30 will be our dinner break. Guys, just enjoy naming all this stuff. Just enjoy it. Just enjoy it. Because this is the easiest thing which you can ever have. Okay, look at this particular one. Both the rings have got equal number of carbon atoms. Now this ring is substituted. Let me start the numbering from spirocarbon. No, not from the spirocarbon. The carbon adjacent to spiro. Either this or this. Since this is substituted, so I'm starting from here. 1, 2, this is 3, this is 4. Let's call this as 5, this is 6, this is 7. So it's going to be 1, 2 dimethyl. 1, 2 dimethyl. Then it's going to be spiro. It's going to be spiro, right? 1, 2, 3. 3 carbon atoms. 1, 2, 3. 3 carbon atoms, right? Then it's in total, how many carbon atoms do you see? 7 carbon atoms. So it's hept. Everywhere there's a single bond, so it's heptane. Are you understanding all this? Sir, in spiro compounds, numbering is confusing. You have to do numbering in that particular ring first, which contains lesser carbon atoms. Okay, have an eye properly here. See, there are 2 rings. Leave this carbon aside. Leave this aside. How many carbon atoms are here? 1, 2, 3, 4, 5. 5 carbon atoms. Leave this carbon aside. 1, 2, 3, 4. 4 carbon atoms. So we are going to do numbering in that ring first, which contains lesser carbon atoms. So I'll do the numbering here first, in this particular ring. Though not from the spirocarbon, the carbon adjacent to spiro, right? Now it can be either this one or this one. Since this one carries the double bond, so prioritize this. This is carbon number 1. This is carbon number 1. This is carbon number 2. This is 3. This is 4. This is 5. This is 6. This is 7. This is 8. This is 9. This is 10. Right? What do you think will be the name of this compound now? What do you think will be the name of this particular compound now? So at carbon number 2, what do we have? At carbon number 2, we have got methyl. At carbon number 2, we have got methyl. Then, since it's a spiro compound, so I'll be writing spiro. Spiro, right? The one that contains lesser carbon atoms. 1, 2, 3, 4. Spiro. So it's going to be 3. 1, 2, 3, 4. So it's going to be 4. It's going to be 4, comma. 1, 2, 3, 4, 5. 4, comma 5. Total how many carbon atoms? 10. So it's going to be dec. At carbon number 1, there is double bond. So it's 1 and it's going to be ene. Perfect. This is the name of the compound. Am I clear? Yes, I'll be taking hydrocarbons as well. Just wait. By the way, day after tomorrow at 8 p.m. Day after tomorrow at 8 p.m. There is one amazing surprise for all of you. Okay? So, do join that particular session. Do that particular session. Do join that particular session. Day after tomorrow, guys. Let me show that to you. Let me show that session to you. It is when I go into the live category. So here comes the session which is scheduled day after tomorrow, and you are going to love it. Okay? And do not forget to smash the like. I've already liked the session though. And do not forget to smash on. Okay? This is something very important. Day after tomorrow, exactly at 8. This is going to ease out your preparation a lot. And particularly, it is for those students who have not completed their syllabus yet. Those students who lately got serious about their preparation. Yeah? Okay? Now, guys, moving ahead. Now, guys, moving ahead. All right. Can you tell me the name of these compounds now? Again, these are spiro compounds. So first of all, I'm going to write the term spiro. Spiro is mentioned, right? Now, this particular ring contains 1, 2, 3. 1, 2, 3, 4. So this one to prioritize, call this carbon number 1. This is 2. This is 3. This is 4. This is, for example, 5. This is 6. This is 7. This is 8, right? So it's going to be spiro. In the smaller size ring, 1, 2, 3. 3 carbon atoms. In the larger size ring, 1, 2, 3, 4. 4 carbon atoms. In total, how many carbon atoms? 8. So it's oct, right? At carbon number 6, there is a double bond, so it's ene. Correct? Correct, people? At the same time, look at this one. Prioritize the smaller size ring first. Yeah? So calling this as carbon number 1. This is, for example, 2. This is 3. This is 4. This is 5. Now this will be 6. Why this is 6? Why this is not 6? Because this one is substituted. 6. This is 7. This is 8. This is 9. This is 10. Now, at carbon number 6, you have got ethyl. At carbon number 7, you have got methyl. Ethyl starts with E. Methyl starts with M. Prioritize ethyl first. Because E comes first, then comes M. Ethyl, methyl. E starts with E. Ethyl starts with E. Methyl starts with M. E comes first, then comes M. Okay? Right? So it's going to be, first of all, 6 ethyl. it's going to be 6-ethyl. Then comes 7-methyl. 6-ethyl, 7-methyl. Then it's going to be a spiro compound. So call this as spiro. Now, in this smaller sized ring, 1, 2, 3, 4. In smaller sized ring, 4 carbon atoms. In the larger sized ring, 1, 2, 3, 4, 5. Comma 5, right? Total 10 carbon atoms. Total 10 carbon atoms. So it's tech. Everywhere there's single bond. So it's ane. This is going to be the name of the compound. Right? 6-ethyl, 7-methyl, spiro, 4,5, decane. Perfect? Yes, Ajay. You're doing great. Amazing. Now, guys, comes one more compound, that is bicyclo compound. So till now I was talking about the spiro compounds. Now let's talk about the bicyclo compound first. Let's talk about the bicyclo compound. Let's talk about the bicyclo compound first. So how do you name the bicyclo compounds? First of all, what are bicyclo compounds? Again, two rings having 2 atoms in common. Not just one, 2 atoms in common. Bicyclo, right? Okay, these are 2 rings having 2 atoms in common, not just one. If there was 1 atom in common, then spiro. If there are 2 atoms in common, then it's going to be bicyclo compound. Then we use the term bicyclo. If there is between 2 rings, there is 1 carbon atom in common, so it's spiro. Between 2 rings, if 2 rings are fused basically with the help of 2 carbon atoms, you call them as the bicyclo. So this is a bicyclo. Now the point is, how do you name the bicyclo compound? How do we name the bicyclo? Okay, how do we name the bicyclo compound? Have a look, guys. Have a look. First of all, is it a spiro compound or bicyclo? It's a bicyclo compound. That's clear? Because 2 rings attached, right? And 2 carbon atoms in common. 2 rings, 2 carbon atoms in common. 2 rings, 2 carbon atoms in common, right? So all of them are bicyclo. All of them are bicyclo. Now, how do we do the numbering in bicyclo compounds? How do we do the numbering in bicyclo compounds? Just opposite of what we did in spiro. Just opposite of what we did in spiro. So first of all, you are going to start the numbering from this particular common carbon. Either this or this. So calling this is carbon number 1. Now go towards the bigger size ring. Go towards the bigger size ring. This is 2, this is 3, this is 4, this is 5, this is 6, now this is 7, and this is 8. Okay? Right? Okay, first of all, go towards the bigger size ring. Then go to the smaller size ring. Now, my dear students, if I ask you one thing. If you want to go from carbon number 1 to carbon number 6. If you want to go from carbon number 1 to carbon number 6. How many paths do I have to go from 1 to 6? This is path number 1. This is path number 2. And this is a direct path. Okay. This is the longest path. This is the longest path. This one is comparatively shorter. This is shorter. And this particular path is shortest. If you want to go from 1 to 6, then this is the longest path. This is comparatively shorter path. This is the shortest path. Now, in this longest path, apart from these 2 carbon atoms, how many do we have? 1, 2, 3, 4. So 4, comma. In the shorter path, apart from these 2 carbon atoms, how many do you have? 1, 2, 4, comma 2. If you talk about the shortest path, apart from these 2, is there any carbon in the middle? No. So 4, 2, 0. 4, 2, 0. Now, in total, how many carbon atoms? 8. So it's going to be oct. Everywhere there is single bond. It's ane. Did you understand how am I doing the numbering? Did you understand, people, how am I doing the numbering? Yeah? Did you understand? Did you understand how am I doing the numbering in such kind of the compounds? Now have a look. Now have a look. Let's say you're starting from here. This is, for example, your carbon number 1. Right? This is carbon number 1. Now, should I go in this direction or should I go in this direction? Both are equal. Both the paths have got equal length. So this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. Call this as 7, call this as 8. Okay? So first of all, it's bicyclo. It's bicyclo. Now, apart from these two, 1, 2, in this particular path, apart from these two, 1, 2, in the middle, 1, 2, 2, 2, 2. Perfect. So in total, 8 carbon atoms. So it's oct. Everywhere there's a single bond. So it's octane. I believe this is clear to everyone. Okay. Now talk about this one. Start from this particular carbon, for example. Or from this, the choice is all yours. I'm starting from bicyclocarbons. Now I have to go to that particular ring which contains more number of carbon atoms. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Now this is 7, this is 8. Okay. So first of all, it's going to be 7,8 dimethyl. 7,8 dimethyl. 7,8 dimethyl. Then the compound is bicyclo. It is bicyclo, right? In the bigger sized ring, how many carbon atoms? 1, 2, 3, 4. In the bigger sized ring, 4 carbon atoms. In the smaller sized ring, how many? How many in the smaller sized ring? 1, 2. Right? In the middle, do you see any carbon between 1 and 6? No. 4, 2, 0. In total, how many carbon atoms? 8. So it's oct. Everywhere there is a single bond? Yes. So it's ane. So this is going to be the name of the compound. Perfect. I believe this is clear to everyone. Now, for example, these are more compounds. Just try to name them. So first of all, you have got 2 rings fused together, right? So it's a bicyclo compound. I'm starting from here, 1. Now, which one is bigger sized? 1, 2. 1, 2, 3. This one is bigger sized. 1, 2, 3, 4, 5, 6, 7, and this one is 8. Okay. So first of all, what do? I write bicyclo. Then, bigger sized ring contains 1, 2, 3 carbon atoms. Smaller one, 1, 2 carbon atoms. In the middle, how many? In the middle, there is 1 carbon atom, right? In total, there are 8 carbon atoms. So oct, everywhere there is a single bond, so it's ane. Right? Perfectly done. Now talk about this one. First of all, you have got 2 rings, right? Fused together. So it's a bicyclo compound. So calling this 1. Now the choice is all yours, whether to do the numbering from this side or this side, because both the sides are equal in length. So 1, 2, this is 3, this is 4. So again, it's bicyclo. Right? In this particular path, 1 carbon atom. In this particular path, 1 more carbon atom. In the middle, there is no carbon atom. 1, 1, 0, right? Total 4 carbon atoms, so it's but. Everywhere is a single bond, so it's ane. Perfect. Right? Look at this one, guys. First of all, let this be carbon number 1. Now, should I go for the bigger sized ring or smaller sized ring? See, if you talk about this particular one, 1, 2, 2 carbon atoms coming in between. 1, 2, 2 carbon atoms are coming in between. So the choice is all yours, either to go from this side or to go from this side. But this side is substituted. So prioritize this. So 1, 2, this is 3, this is 4, this is 5, this is 6, and this one is going to be 7. Perfect. So it's going to be first of all 2, 3 dimethyl. 2, 3 dimethyl. 2, 3 dimethyl. Perfect. Then it's going to be bicyclo. Then it's going to be 2, 2, 1. Bicyclo 2, 2, 1. Perfect. In total, there are 7 carbon atoms, so hept. Everywhere it's a single bond, so it's ane. Is it clear? Is it clear, people? Is it clear? I believe this is clear. And if this is clear, try to give name to these compounds as well. Let this be carbon number 1. Now, this side as well as this side, both are equal in length. 1, 2, 1, 2. 2 carbon atoms in both the sides, right? And this one carries the double bond, so prioritize this. 1, 2, 3, this is 4, this is 5, this is 6, and this is 7 here, right? So it's first of all going to be bicyclo, right? If you want to go from 1 to 4, how many paths you have to go from 1 to 4? This is 1 path, this is 1 more path, this is 1 more, right? These 2 paths are identical, right? I mean, they are equal in length. There are 2 carbon atoms in between. So it's 2, 2, in the middle, there is 1 carbon atom. So 2, 2, 1. Okay. So 7 carbon atoms in total. So it's going to be hept. Add carbon number 2. There is a double bond. So it's going to be ene. Hept to ene. Done with this? Okay. Talk about this one. Let's call this is carbon number 1. This is, for example, 2. This is 3. This is 4. This is 5. This is 6. Right? So it's first of all bicyclo. Right? Now, if you want to go from 1 to 4, this is one path, this is one more path, this is one more path, right? These two paths have got equal length. This path as well as this path have got equal length. So it's going to be 1, 2. Okay, wait, I forgot to write one thing. So first of all, it's going to be 2, 3 dimethyl, 2, 3 dimethyl, 2, 3 dimethyl. Then I'll be writing bicyclo. Then it's going to be 1, 2, 1, 2, and 0 in the middle, right? So 2, 2, 0, 2, 2, 0, right? In total, 6 carbon atoms. So it's going to be hex. Everywhere is a single bond. So it's ane. Correct? Perfectly done. Look at this one. Let me start the numbering from this particular carbon. This is carbon number 1. Now both are identical, but this one is substituted. So 2, this is 3, this is 4, this is 5, this is 6, this is 7, this is 8, this is 9, and this is 10, right? So it's first of all going to be 3, 4 dimethyl. 3, 4 dimethyl. 3, 4 dimethyl. Then it's going to be a bicyclo compound. It's going to be bicyclo. Now, from 1 to 6, this is one path, this is one more path, and this is one more path, right? See, this path and this path have got equal length. That means 1, 2, 3, 4. 1, 2, 3, 4. 4 carbon atoms. So it's going to be 4, 4. 4, 4, comma. In the middle, between 1 to 6, is there any carbon? No. So 4, 4, 0. In total, how many carbon atoms? 10. So it's going to be dec. Everywhere is a single bond? No. At carbon number 3, there is a double bond. So dec 3 ene. Okay, guys? Yeah? Right? Yes, Ajay, if there are 2 double bonds, then you will use A, hepta or hexa, whatever, if there are 2 double bonds. All right. Tell me the name of this particular compound. Tell me the name of this particular compound. So I selected my 2 carbon atoms first, right? Which are common to both the rings. Now, first of all, if you talk about 1, 2, 1, 2. So both the sides are equal in length. So let me start from this particular carbon, this carbon number 1. Now, here also carbon number 2 gets the double bond. Here also carbon number 2 gets the double bond. But this is substituted also. So call this 2, call this 3. This is 4, this is 5, this is 7, 6, and this is 7. So it's first of all going to be 2, 3, 2, 3 dimethyl, right? 2, 3 dimethyl. It's going to be 2, 3 dimethyl. That is going to be bicyclo. 2, 3 dimethyl bicyclo. 1, 2, 1, 2. So 2, 2, in the middle there is one carbon atom. So 2, 2, 1. So total how many carbon atoms? 6. So it's hex. Is it going to be hex or hexa? So in the main chain there are 2 double bonds. So it's going to be hexa, right? It's going to be hexa. Add carbon number 2 and carbon number 5. Add carbon number 2 and carbon number 5. It is diene, right? Add carbon number 2 and carbon number 5. It is diene. Yes? Okay, guys? All right. Now we are going to start the compounds. Now we are going to start the compounds wherein we are going to use the functional groups. But we'll be doing that after the dinner break. My dear students, I am giving you a dinner break. I am giving you to the dinner break till how much time? It's 9:28 till 10 p.m. 30 minutes break I'm giving you. So be back on time exactly. Okay? Be back on time, everyone. Be back on time. Wait. 7 carbon atoms. So this is hexa. This is not hexa, sorry. This is hepta. This is hepta. This is not hexa. Because there are 7 carbon atoms. Yes. It's hepta. So I'll see you exactly at 10 p.m. and be back on time, okay? Be back on time. Saying, sir, hexa, not hepta. It's hepta, not hexa. I'll see you in a while. After Guys, can you hear me? Can you hear me now? I don't know there was something wrong. There was something wrong. I don't know. Is it fine now? Just tell me quickly, is it fine now? Isomerism you'll be getting soon. Just wait, just wait. Let me complete IUPAC first. Let me know once in the chat, people. Is everything fine now? Yeah? Yes, I'm done with my dinner. What about you? Are you guys done? Are you guys done with your dinner? The class will be over in like 1.5 hours. Yes, even JEE students can also watch it. Yes, 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 yes. Okay, so tell me whatever things I've discussed till now, is every single thing clear? First, we discussed the alkanes, then alkenes, then alkynes. Then we discussed the cyclocompounds. Then we talked about the spirocompounds. Then we talked about the bicyclic compounds. Yeah? So tell me once in the chats if every single thing discussed till now is clear to you or not. You sure we'll be doing thermodynamics part 2 as well. Just wait. Everyone in the chats. Now we are going to see the functional groups basically. Okay. Now we are going to talk about the functional groups. So first of all, we are going to see the IUPAC naming of the compounds which have got the functional groups. Okay. IUPAC naming for the compounds which have got the functional groups. That's something which we shall be discussing now. And we shall be discussing with what? We shall be discussing with the carboxylic acid, COOH. Okay. We shall be discussing with the carboxylic acid. We shall be discussing with this particular functional group, C double bond OH. What do we call this particular functional group as? We call this as the carboxylic acid. Now, my dear students, there are just two things which you need to remember. Just two things which you need to remember. Something which is written on this particular slide. My dear students, as a suffix, we use two names. As suffix, we use two names. One is oic acid and one is carboxylic acid. When we use the suffix as oic acid and when do we use the suffix as carboxylic acid? Two things again you have to remember. If the carbon of carboxylic acid, is the part of the main chain, then we use the suffix as oic acid. If the carbon of the carboxylic acid is not the part of the main chain, then we use carboxylic acid. First of all, remember these two things. As suffix, we give two names to this carboxylic acid. One is your oic acid, one is particularly carboxylic acid. When the carbon of the main chain is the part of the, when the carbon of the carboxylic acid is the part of the main chain, we use oic acid. And if the carbon of the carboxylic acid is not the part of the main chain, then as a suffix, we use carboxylic. Point number one. Point number two. As prefix, we use the term carboxy. As prefix, we use the term carboxy. Let's get to know the meaning of all this through examples. Let's get to the meaning of all this through examples. For example, my dear students, look at this particular slide. Look at this particular slide. If you see, this is C double bond OOH. So this is your carboxylic acid here. This is the functional group carboxylic acid. Okay. Now, first of all, if I give the naming, if I start the numbering, I'll start the numbering from the carbon of carboxylic acid. So this carbon number 1, this is 2, this is 3, and this is 4. So first of all, 4 carbon atoms means but. Everywhere you can see there's a single bond, so it's ane. Butane. At carbon number 1, what do you see? You have got the functional group, which is carboxylic acid. Now the carbon of the carboxylic acid is the part of the main chain. Carbon of the carboxylic acid is the part of main chain. And when the carbon of carboxylic acid is the part of main chain, then as a suffix, what do we use? We use oic acid. We use oic acid. Now, after this E, as you can see, vowel sound is starting, so drop the C. So, butane, 1 oic acid. Clear? Similarly, my dear students, look at the next one. Again, you can see C double bond OOH. This is again the carboxylic acid. Now, this is carbon number 1, this is 2, this is 3, and this is 4. So, first of all, it's going to be 2, 2 dimethyl. 2, 2, it's going to be dimethyl. 2, 2 dimethyl. Now, in the main chain, 4 carbon atoms. So, it's but. Everywhere single bond, so it's ane. At carbon number 1, you have got COOH group, right? This is the carboxylic acid. And the carbon of carboxylic acid is the part of main chain. So, I'll write 1 oic acid. 1 oic acid. And drop this E here, because after this E, vowel sound is starting. Correct? Talk about this one. This is your carbon number 1, this is 2, this is 3, and this is 4. Right? So, I'll be starting with, first of all, but. Everywhere single bond, ane. Right? Now, at 1 and 4, at 1, 4, it's going to be dioic acid. It's going to be dioic acid. Butane, 1,4-dioic acid. Yes? I believe this is clear to everyone. I believe this is clear to everyone. Okay? Let me take 5 more examples. Let me take 5 more examples. This example is important, guys. This particular example is important. So, how many carboxylic acids do you see here? This is C double bond OOH. Again, C double bond OOH. And if you see clearly, this is again your C double bond OOH. So, there are 3 functional groups. There are 3 carboxylic acids. There are 3 carboxylic acid groups attached, right? And every carbon of the carboxylic acid is directly attached to the chain. Every carbon of the carboxylic acid is directly attached with the chain. Whenever you have this sort of the scenario wherein more than 2 carboxylic acids are attached through carbon with respect to the chain, then none of the carbon of the carboxylic acid is to be considered in the main chain. Then none of the carbon of the carboxylic acid is included in the main chain. So let me call this as carbon number 1, this is 2, this is 3. Okay, you have 3 carboxylic acids. Perfect. And all the carbons of carboxylic acids are directly attached with the chain. Perfect. So none of the carbon is considered here when you do the numbering. None of the carbons of carboxylic acid is considered. So the name of this particular compound is going to be propane. Propane 1, 2, 3. 1, 2, 3. Then it's going to be tri. Since none of the carbon of the carboxylic acid is the part of the main chain, so I'll be using the suffix as carboxylic acid. Tricarboxylic acid. Okay. Perfect. Now similarly, if we talk about this one, this is your cyclohexane. And here's a carboxylic acid. This carbon is attached with this carbon is attached with this carbon is attached with this. So you have got 3 carboxylic acids. None of the carbon of the carboxylic acid is considered while numbering, right? So let me start the numbering, for example, from here. 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it's going to be, first of all, cyclohexane. It's going to be cyclohexane 1, 2, 4. Cyclohexane 1, 2, 4. And it's going to be tri. Should I write oic acid as a suffix or carboxylic acid? Since none of the carbon of the carboxylic acid is the part of the main chain, so it's going to be carboxylic acid. Okay, it's going to be carboxylic acid. As suffix, we use 2 things, either oic acid or we use carboxylic acid. Oic acid is used when the carbon of carboxylic acid is the part of main chain. And carboxylic acid is used as a suffix when the carbon of carboxylic acid is not the part of the main chain. Okay? Perfectly done. So tell me the answer of this particular question. Again, do you see, is it bicyclo or spiro? It's a bicyclo compound, right? And in case of bicyclo compounds, I'll be starting from this particular one. This is, for example, carbon number 1. Now, talk about this particular ring. How many carbon atoms do you see in this ring? 1, 2, 3, 4. In this particular one, 1, 2, 3, 4. So both have got equal number of carbon atoms, right? So which one to prioritize? The one wherein carboxylic acids are attached, I'll prioritize that one. So 2, this is 3, this is 4, this is 5, 6, 7, 8, 9. And this is 10. Perfect. So I'll be first of all writing bicyclo. Bicyclo. And it's going to be 1, 2, 3, 4. 1, 2, 3, 4. It's going to be 4, 4. In the middle, there is no carbon atom. 4, 4, 0. Right? Then there are 10 carbon atoms, so it's dec. Everywhere single bond, so ane. Dec ane. Add carbon number 3 and carbon number 4. Add carbon number 3 and carbon number 4. What do we have? Add carbon number 3 and carbon number 4. We have got carboxylic acids. And none of the carbon of carboxylic acid is the part of the main chain. So it's going to be 3, 4 dicarboxylic acid. Did you understand this particular one? Yeah? Is it clear, guys? Look at this one. Look at this one. Look at this one, guys. Look at this one. Can you name this particular compound? This is important. Tell me the name of this particular one. Tell me the name of this particular one. Quickly. Tell me the name of this particular one, quickly. Yes, even JEE students can also watch it. Yes, absolutely. Tell me the name of this particular compound. I'm waiting for your answers. I want to know, what do you think about this particular compound? Quickly. Quickly, everyone. Quickly, everyone. I'm waiting for your answers. Quickly, guys. Looking at your chats. Everyone, I'm waiting in the chats. Quick. All right, let me try it. So first of all, let me call this as carbon number 1. This will be 2, this will be 3, this will be 4, this will be 5, and this will be 6, right? At carbon number 2, what do you see? At carbon number 2, I'll say, at carbon number 2, I'll use this as the prefix. I'll use this as a prefix. So what is going to be its name since it's prefix? So first of all, add carbon number 2. Add carbon number 2. What do I write? Let me see what people have said in the chats. Do you see it's a complex substituent at carbon number 2? The complex substituent, right? Add carbon number 2. Now again start the numbering here. This is 1. This is 1. Now this is going to be, as prefix, what do we use? We use carboxy. So it's going to be carboxymethyl. It's going to be carboxymethyl. Carboxymethyl, right? Now it's a cyclo compound, right? It's going to be cyclohexane. Cyclohexane, right? Now at carbon number 1 and carbon number 4, it's going to be 1, 4. Is it going to be dioic acid or dicarboxylic acid? Since none of the carbon of the carboxylic acid is the part of the main chain, so it's going to be simply dicarboxylic acid. Dicarboxylic acid. I believe this is clear to everyone, right? Okay, talk about this one. It's again a spiro compound. It's a spiro compound, right? Now, in the spiro compound, what do we do? In the spiro compound, from where do we start the numbering? From that ring which is smaller in size. 1, 2, 3. 1, 2, 3, 4. So this one is smaller. So call this as carbon number 1. This is 2. This is 3. We don't start with the spiral carbon. We start the numbering from the carbon which is adjacent to spiral carbon. So this is 3. This is 4. Now this is 5. This is 6. This is 7. This is 8. So it's spiro. How many carbon atoms in the smaller ring? 1, 2, 3. 3 carbon atoms in the smaller ring. In the bigger sized one, 1, 2, 3, 4. 4 carbon atoms in the bigger sized one, right? How many carbon atoms in total? 8, so it's oct. Everywhere it's a single bond, so it's ane. Now at carbon number 6, what do we have? We have got the carboxylic acid, right? Since the carbon of the carboxylic acid is not the part of the main chain, so it's directly 6 carboxylic acid. Right? Perfect. All right. I'm moving ahead, guys. So this was all about your what? This was all about your carboxylic acids. Now there is one more functional group, that is CN. You know it already. Now again, when it comes to your CN functional group, there are again two things which you have to remember. When we use the suffix for CN, we use two things. Either we use nitrile or we use carbonitrile. Either we use nitrile as a suffix or we use carbonitrile as a suffix. When is nitrile used and when is carbonitrile used? Nitrile is used when the carbon of this particular group is the part of the main chain. And carbonitrile is used when the carbon of CN is not the part of the main chain. So either it's going to be nitrile or it's going to be carbonitrile. Perfect. When the carbon of CN is the part of main chain, then nitrile as the suffix. When the carbon of this CN is not the part of the main chain, then it's going to be carbonitrile. And as a prefix, we use cyano. As a prefix, what do we use? We use cyano. As prefix, we use cyano. For example, have a look. If I talk about this particular compound, all this is carbon number 1, this is 2, this is 3. So first of all, it's going to be 2-methyl. It's going to be 2-methyl. Now it's going to be propane. Propane. Now at carbon number 1, what do we have? This is CN. This is CN, right? And the carbon of CN is the part of the main chain. So it's going to be nitrile. Propane 1-nitrile. Perfect. Now similarly, talk about this one. Carbon number 1, this is 2, this is 3, and this is 4. Perfect. So at carbon number 3, what do we have? Methyl, methyl. So it's 3,3 dimethyl. It's going to be 3,3 dimethyl. Now 4 carbon atoms in the main chain. So it's but. Everywhere single bond, so ane. Butane. Right? Now the carbon of CN is the part of main chain. So it's going to be 1-nitrile. 1-nitrile. Yes? Look at this one. It's going to be 1, 2, 3, 4, 5, 6. Right? So it's going to be cyclohexane. Cyclohexane 1. Is it going to be nitrile or carbonitrile? See, this was 1, this was 2, this was 3, 4, 5, 6. Since the carbon of CN is not the part of the main chain, so as the suffix, I'll be using carbonitrile. I'll be using carbonitrile. Am I clear with this? I believe all this is clear. Let's move on to a few more. Now again, this is, for example, carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. So first of all, it's cyclohexane. Now at 1 and 2, what is it going to be? Is it going to be dinitrile or dicarbonitrile? Since none of the carbon of CN is the part of main chain, so as the suffix, I'll be using carbonitrile. So it's dicarbonitrile. It's going to be dicarbonitrile. Correct? Look at this one. Again, it's a bicyclo compound. And in the bicyclo compounds, we start the numbering either from this carbon or this carbon. So start from here. Call this carbon number 1. Now, both these rings have got equal size. So anyone can be prioritized. But I'll be prioritizing this ring. Why? Because there are cyanide groups attached with this ring. So call this carbon number 2. This is 3. This is 4, 5, 6, 7, 8, 9, 10. So first of all, it's a bicyclo compound. Right? Now, in this particular ring, 1, 2, 3, 4, 4 carbon atoms. In this particular ring, 1, 2, 3, 4, 4 carbon atoms. In the middle, there is no carbon atom. So 4, 4, 0. So how many carbon atoms in total? 10. So it's going to be dec. Everywhere, single bond, decane. Now add carbon number 3 and 4. You have got 2 cyanide groups, right? And as the suffix, what do we use? Nitrile or carbonitrile? Since none of the carbon of CN is the part of main chain, so I'll be using carbonitrile, but it's going to be dicarbonitrile. Dicarbonitrile. Right? Perfect, guys. Am I clear? Am I clear with this? Similarly, look at this one. It's a spiro compound. You know it already. It's a spiro compound. So first of all, I'll be writing spiro. Now do the numbering. We have to do the numbering in that ring first, which is smaller in size. 1, 2, 3. 1, 2, 3, 4. So start the numbering from here. Call this as 1. This is 2. This is 3. This is 4. For example, this is 5. This is 6. This is 7. And this is 8. So spiro. The ring which is lesser in size has got how many carbon atoms? 1, 2, and 3. So this is 3. The ring which is bigger in size, 1, 2, 3, 4, has got 4 carbon atoms. So 3, 4. Now total how many carbon atoms? 8. So it's going to be oct. Everywhere there is single bond. So ane, right? None of the carbon of CN group is the part of main chain. So it's going to be 6, 7 dinitrile or carbonitrile. It's going to be carbonitrile. It's going to be carbonitrile. Correct, people? I hope this is clear. I hope this is clear. I hope this is clear. Okay, look at this one. Look at this one. What do you think will be the name of this one? What do you think will be the name of this one? All this carbon number 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Now at carbon number 2, there is a complex substituent. In the complex substituent, you do the numbering separately. So I would say, first of all, at carbon number 2, what do we have? We have got this CN I'll be taking as the prefix now, and when as a prefix we use the term cyano. So it's going to be 1 cyanomethyl. It's going to be 1 cyanomethyl. Now it's going to be cyclic compound. So it's going to be cyclo. Now it's going to be cyclo. Cyclo. Since 6 carbon atoms, so hex. Everywhere single bond, so ane. Right? Now add carbon number 1 and carbon number 3. So it's going to be 1, 3. It's going to be di. 1, 3 di. Is it going to be nitrile or carbonitrile? Since none of carbon is the part of the main chain, so it's going to be dicarbonitrile. Perfect? Yes. Look at this one. Which compound is this? It's a bicyclo compound. You can see 2 carbon atoms here common. So let me start the numbering from this carbon. Carbon number 1. Now which one should I prioritize? The bigger sized ring. Now this ring as well as this ring are equal sized. So anyone is preferred. But I'll be preferring this particular one for numbering. Why is that? Because it is substituted. It has got functional groups attached. It has got a pi bond as well. So if this is carbon number 1, this is 2, then this has to be 3, this has to be 4, this is 5, this is 6, 7, 8, 9, and 10. Right? So I'll be first of all using the term bicyclo. Perfect. Now, in this particular ring, 1, 2, 3, 4 carbon atoms. In this particular ring, 1, 2, 3, 4 carbon atoms. In the middle, there is no carbon atom. So 4, 0. Now, how many total carbon atoms? 10. So it's dec. Everywhere it's a single bond. So it's ane. Dec ane. Now add carbon number 3 and carbon number 4. What do we have? Sorry, it's not ane. It is dec. Add carbon number 3. What do we have? We have got double bond. So it's 3 ene. It is 3 ene. Dec 3 ene. Right? Now, dec 3 ene. Now add carbon number 3 and 4. It's going to be 3, 4. Now, is it going to be dinitrile or dicarbonitrile? Since none of the carbon of cyanide is the part of main chain, so it's going to be dicarbonitrile. Did you understand this one? Right? Did you understand this particular case? Did you understand this one? All right. Now, my dear students, there is one more important functional group. What is that? That is your aldehyde group. That's your aldehyde group. That's your aldehyde group. Perfect. Now, again, in case of aldehydes, what all things you have to remember? The first thing, As suffix, either we use L, Al, or we use carbaldehyde. As suffix, either we use Al or we use carbaldehyde. That depends on if the carbon of this aldehyde is the part of main chain or if the carbon of this group is not the part of the main chain. If the carbon of aldehyde group is the part of main chain, then as suffix I'll be using Al. And if the carbon of the carboxylic, if the carbon of the aldehyde group, if the carbon of the aldehyde group is not the part of the main chain, is not the part of the parent chain, then I would use the prefix, I would use the suffix as carbaldehyde. Right? Yes? So as suffix, either Al or carbaldehyde. If the carbon of aldehyde is the part of main chain, then use the suffix Al. If the carbon of the aldehyde is not the part of the main chain, then use the suffix as carbaldehyde. And let me tell you, as prefix, what do we use? As prefix, we use simple formyl. We use formyl. Now, let's try to name certain compounds. What do you think will be the name of this particular compound? This is 1, this is 2, this is 3, this is 4. This is CHO group, right? CHO group. This is aldehyde. And the carbon of this aldehyde group is the part of the main chain. So it's but, everywhere single bond, so ane, right? Add carbon number 1, it's going to be Al. Why? Because the carbon of aldehyde is the part of the main chain. Perfect. And since after this E vowel sound started, so drop this E here. Drop this E here. Perfect. Look at the second case, guys. Look at the second case. If this is carbon number 1, this is carbon number 2, this is 3, and this is 4. So it's going to be 2, 2. It's going to be 2, 2. It's going to be dimethyl. 2, 2 dimethyl. 2, 2 dimethyl. Now it's going to be butane. But everywhere is a single bond, so ane. Now carbon of aldehyde is the part of the main chain. So at 1, it's going to be Al as the suffix. So drop this E. Drop this E. Right? Talk about this one. This is 1, this is 2, this is 3. Right? So it's going to be prop. Everywhere single bond. So ane. Propane. Now at 1 and 3. At 1 and 3. You have got two functional groups. Aldehyde, aldehyde. Carbon of this aldehyde as well as carbon of this aldehyde is the part of the main chain. So it's going to be di-Al. Al. I'm going to use Al as the suffix. Perfect? Is it clear? If it is clear, let's move on to a few more examples. Let's move on to a few more examples. Look at this one, guys. Carbon number 1, carbon number 2, 3, this is 4, this is 5, this is 6. So first of all, it's a cyclic compound, so cyclo. 6 carbon atoms in the main chain, so hexane. At carbon number 1 and 2, what do you see? You see 2 aldehyde groups. And none of the carbon of the aldehyde is the part of the main chain. So which suffix I'll be using? Should I be using Al or carbaldehyde? So 1, 2, di-carbaldehyde. Okay. Talk about this one. It's a bicyclo compound. Start with this particular carbon. Start with this particular carbon. Now, which ring to prioritize? Both the rings are equal sized, but you're going to prioritize this particular one because there's a functional group attached. So 1, 2, this is 3, this is 4, 5, 6, 7, 8, 9, and 10. Right? So it's a first of all bicyclo compound. So it's going to be bicyclo. In this particular ring, how many carbon atoms? 1, 2, 3, 4, 4 carbon atoms. In this particular ring, how many? 1, 2, 3, 4, 4 carbon atoms. In the middle one, there is no carbon atom. So 4, 4, 0, right? There are total 10 carbon atoms, so it's dec. Everywhere is a single bond, so ane, right? Now at carbon number 2, there is an aldehyde group. Now this particular carbon of aldehyde is not the part of main chain, so I'll be writing directly suffix as carbaldehyde. I hope you are following all this. Yeah? I hope you are following all this. Which compound is this one? Is it bicyclo or spiro? This compound is spiro. 1 carbon atom in the middle. And in the spiro, from which ring we do the numbering? We do the numbering from that ring which is smaller in size. Now, which ring is smaller in size? 1, 2, 3. 1, 2, 3, 4. So this ring is smaller in size. So let me start the numbering from here. 1, 2, 3, 4. Right? 1, 2, 3, 4. This is going to be 5. This is going to be 6. This is going to be 7. And this is going to be 8. Now at carbon number 7, we have got a complex substituent. At carbon number 7, we have got a complex substituent. So we have to do numbering to this complex substituent first. Just a second. There are a lot of wires here. Okay. At carbon number 7, there is a complex substituent. Now, this particular one, this CHO group, should I be treating this as suffix or prefix? I'll be treating this as prefix. And as prefix, what do we use? We use formyl. So first of all, add carbon number 7, if this is 1, so it's going to be formyl methyl. It's going to be formyl. Add carbon number 7. Now let me write first of all 1. Then I'll write formyl methyl. Formyl methyl. This one is done. Formyl methyl. Now it's a spiro compound. So write spiro. Write spiro. How many carbon atoms in the smaller sized ring? 1, 2, 3. How many carbon atoms in the bigger sized ring? 1, 2, 3, 4. 3, 4. Total, how many carbon atoms do you see? 8. 8 means oct. Everywhere do you see single bond? Yes. So it's ane. It's ane. Now at carbon number 6, you have got aldehyde group. Now the carbon of aldehyde group is not the part of the main chain. So should I write L or carbaldehyde? I'll be writing carbaldehyde. Okay, this is going to be its name. Perfect. I believe this is again clear to everyone. Okay. Tell me the name of this particular compound. Here you can see two functional groups. This is your carboxylic acid. This is your aldehyde. Now, among carboxylic acid and aldehyde, which one is prioritized? Carboxylic acid is prioritized. And the one that is prioritized, that has to be used as suffix, and the one which is not prioritized, that has to be used as prefix. Right? Now, as prefix aldehyde, we use formyl. Okay. Carboxylic acid, when used as suffix, we use what? We use either oic acid or carboxylic acid, depending on whether this particular carbon is the part of the main chain or not. Yeah. So what should be the name of this compound? Start with this carbon. 1, 2, 3, 4, 5, and 6. So first of all, I'll write 3-formyl. Then it is cyclohexane. Cyclohexane. At carbon number 1, there is COOH group. Since the carbon of this carboxylic acid is not the part of the main chain, so I'll use the suffix as 1-carboxylic acid. 1-carboxylic acid, right? Perfect. So this is going to be its name. If I'm clear till here, tell me once in the chats quickly. Perfect. All right. Now let's talk about one more functional group. That is your amide. CONH2. This is your amide functional group. Now again, two things you have to remember. What things do we use as suffix and what things do we use as prefix? As suffix, we use two things, either amide or carbamide. We use either amide or carbamide, depending on if the carbon of this amide group is the part of main chain, then as suffix we use amide. If the carbon of this amide group is not the part of the main chain, then we use the suffix as carbamide. Okay, we use the suffix as carbamide. And let me tell you, as prefix, we use carbamoyl as prefix. Let me take certain examples which will make things clear. So amide, carbamide, carbamoyl. Okay, amide, carbamide, carbamoyl. For example, look at this particular example. Carbon number 1, this is 2, this is 3, this is 4. So this is first of all but, everywhere single bond, so it's ane. At carbon number 1, what do we have? You have got amide group, and the carbon of this amide group is the part of the main chain. Perfect. So as the suffix, I'll be using butane 1-amide. And you are going to drop this E because after this E, vowel sound is starting. Right? If you talk about this one, this is your carbon number 1, this is 2, this is 3. Right? So first of all, I'll be writing prop. Everywhere it's single bond. So it's propane. Right? At 1 and 3. What is going to be? Is it going to be diamide or dicarbamide? Since carbon of both these functional groups is the part of the main chain, so it's going to be diamide. I'll use amide as the suffix. Right? Propane 1,3-diamide. Perfect? Perfect, guys? If you look at this one, all this carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it's first of all cyclohexane. It's first of all cyclohexane. Now at carbon number 1, what do we have? We have got the functional group, amide. Since the carbon of this functional group is not the part of the main chain, therefore, as the suffix, should I use amide or carbamide? I should use carbamide. Perfect. I should use carbamide here. Okay, talk about this particular compound. Talk about these particular compounds. So, let me do one thing. Let me call this as carbon number 1, this is 2, this is 3, this is 4, this is 5, and this is 6. So, first of all, it's again cyclohexane. It's cyclohexane. And then it's going to be 1, 3. Then it's going to be di. None of the carbon of amide is the part of the main chain. So, the suffix used is going to be, what is it going to be? It's going to be amide or carbamide? It's going to be carbamide. Dicarbamide. Perfect? Dicarbamide. Perfectly done? Look at this one. This is a bicyclo compound. And in the bicyclo compound, we start the numbering either from this carbon or this carbon. Now, I'll be starting from here. Now, my dear students, both the rings have got equal size. So, prioritize any one for numbering. But you'll be prioritizing right now this one. Why? Because there's a functional group attached. So, if this is carbon number 1, this has to be 2, this has to be 3, this will be 4, 5, 6, 7, 8, 9, and 10. Perfect? So, first of all, it's going to be bicyclo. Now, in this particular ring, how many carbon atoms? 1, 2, 3, and 4. Okay? In this particular ring, how many? 1, 2, 3, and 4. And in the middle, between 1 and 6, there is no carbon atom. So, 4, 4, 0. In total, 10 carbon atoms. So, it is dec. Everywhere, it's a single bond. So, it's decane. Now, at carbon number 2, there is an amide group. And since the carbon of the amide group is not the part of the main chain, so should I use the suffix as amide or carbamide? I should be using the suffix as carbamide. As a suffix, I'll be using carbamide. Perfect. I believe all this is done. I believe all of this is done, people. Okay, look at this one. Which compound this is? Cyclic, spiro, or bicyclo? It's a spiro compound. So first of all, you are going to use the term spiro. Now, smaller size ring. 1, 2, 3. 1, 2, 3, 4. This is a smaller size ring. And we are going to start numbering in the smaller size ring first. So this is 1, this is 2, this is 3, this is 4, this is 5, 6, 7, and 8. Right? So, I'll be using spiro. In the smaller size ring, 3 carbon atoms. In the larger size ring, 1, 2, 3, 4. 4 carbon atoms. So 3, 4. In total, how many carbon atoms do you see? 8. So it's oct. Everywhere it's single bond. Octane. Now at carbon number 6, what do we have? At carbon number 6, what do we have? At carbon number 6, there is amide group. Perfect. Now the carbon of this amide is not the part of the main chain. So should I use the suffix as amide or carbamide? I'll be using the suffix as carbamide. Okay. Talk about this one. Now these are 3 functional groups starting with carbon. 3 functional groups starting with carbon. I've told you already. None of the carbon has to be considered in the main chain. Right? Whenever you have more than 2 functional groups, right, which are attached with the chain starting with carbon, none of the functional group is to be included in the main chain. So this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it's first of all cyclohexane. Now, at 1, 2, and 4, 1, 2, and 4, it's going to be tri. What? Amide or carbamide? It's going to be carbamide. Tricarbamide. Why? Because none of the carbon is the part of the main chain. Perfectly done? Perfect? Amazing. Now guys, talk about this one. Two different functional groups are attached. This is carboxylic acid and this is your amide. Okay? Which one is prioritized? Carboxylic acid is prioritized over everything. Carboxylic acid is prioritized over everything. So this is prioritized, right? So for this, I'll be using suffix. For this, I'll be using prefix. So what should I write? As a prefix for this amide group, what should we use? We use, first of all, let me do the numbering. 1, 2, 3, 4, 5, and 6. At carbon number 4, I'll be using carbamoyl. At carbon number 4, I'll be using carbamoyl as a prefix. Now it's going to be cyclohexane. It's going to be cyclohexane. Now at carbon number 1, there is carboxylic acid. So as a suffix for carboxylic acid, we use either oic acid or carboxylic acid. But carbon of this carboxylic acid is not the part of the main chain. So at that point of time, what do we use? We use carboxylic acid. We use carboxylic acid. I believe this is clear. Yes? Am I clear till here? Everyone in the chats? Am I clear, people? Am I clear? Perfectly done? All right, people. Moving ahead. There is one more functional group. What do you call that as? You call that as acid halide. And normally you have got acid chloride. Okay? Acid halide. Acid halide, or particularly which one among acid halides we are going to talk about? We are going to talk about acid chlorides. Okay? Acid chloride means C double bond O Cl. C double bond O Cl. This is your acid chloride. This is one more functional group. Acid chloride. Now, again, as suffix, you have to remember two things. Either oil chloride or carbonyl chloride. As suffix, either we'll use oil chloride or carbonyl chloride. When do we use oil chloride? When the carbon of this functional group is the part of the main chain. We use oil chloride. When the carbon of this functional group is not the part of the main chain, we use suffix as carbonyl chloride. Right? Okay? And as prefix, what do we use? We use chloroformyl. Okay? Basically, in general, it is haloformyl. Since we are talking about acid chlorides, so it's chloroformyl. So basically, as suffix, either you will be using oil chloride or carbonyl chloride, depending on if the carbon of acid chloride is the part of main chain, then as a suffix oil chloride. If the carbon of carboxylic acid, if the carbon of this acid chloride is not the part of the main chain, then as suffix I'll be using carbonyl chloride. And as prefix, what do we use? We use simple chloroformyl. For example, let me take certain examples with the help of which things will be clear. See, first of all, this is C double bond O Cl. So this is the acid chloride. C double bond O Cl, acid chloride. C double bond O Cl, acid chloride. Right? So start the numbering. 1, 2, 3, and 4. So first of all, it's going to be but. Everywhere it's single bond, so it's going to be ane. Now at carbon number 1, what do you see? You have got acid chloride. Now the carbon of acid chloride is the part of main chain. So the suffix used is oil chloride. Suffix used is oil chloride. Now drop this E because after E, vowel sound is starting. Yeah? Perfect, guys? Okay, what about this one? 1, 2, 3, 4, and 5. So it's first of all going to be pent. Everywhere it's single bond, so it's ane. Now carbon number 1, carbon number 5. 1 and 5. Since the carbon of this as well as carbon of this, both are the part of the main chain. So which suffix I should use? Should I use oil chloride or carbonyl chloride? I'll be using oil chloride. But right now, two functional groups, so it's going to be di-oil chloride. Di-oil chloride. Am I clear with this? Everyone? In the chats once. Perfect, guys. Take this particular example. Take this particular example. It is first of all a cyclocompound. First of all, it's a cyclocompound. If I call this as 1, this is 2, this is 3, this is 4, this is 5, this is 6. So it's first of all cyclohexane. It's first of all cyclohexane. Now at carbon number 1 and 3. 1, 3. Okay. Since this carbon of the functional group as well as this carbon of the functional group, they are not the part of the main chain. Therefore, as suffix, I won't be using oil chloride. I'll be using carbonyl chloride. But it's going to be dicarbonyl chloride. It's going to be dicarbonyl chloride. Dicarbonyl chloride. Okay. Now look at this one. It's a bicyclocompound. It's a bicyclic compound. So first of all, we have to start the numbering. Either I'll start from here or I'll start from here. But right now I'll be starting from here. Because closer to this, there is a functional group. Okay. Since both the rings are equal in size. Both the rings are equal in size. So if this is 1, this is going to be 2, this will be 3, this will be 4, 5, 6, 7, 8, 9 and 10. So first of all, I'll be using the term bicyclo. I'll be using the term bicyclo. Since both the rings are equal in size, so 1, 2, 3, 4. 4 carbon atoms in the first ring. 1, 2, 3, 4. 4 carbon atoms. In the middle, between carbon number 1 and carbon number 6, there is no carbon. So it is 0. So 4, 4, 0. So in total, how many carbon atoms? 10. So it's going to be dec. Everywhere, it's a single bond. So it's ane. Now, at carbon number 2 and carbon number 4, at carbon number 2 and 4, right? There are two functional groups, acid chlorides. None of the carbon of the functional group is the part of the main chain. So should I use oil chloride or carbonyl chloride? I'll use dicarbonyl chloride as the suffix. Am I clear? Am I clear, people? Am I clear? Everyone? It's going to be a simple one now. Which compound this is? It's a spiro compound. It's a spiro compound. From which ring should I start the numbering? The smaller sized ring. Should I start the numbering from spirocarbon? No. The adjacent one. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8 and 9. Okay. So it's going to be spiro. In the smaller sized ring, how many? 1, 2, 3. In the larger one, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 3, 5. Total how many carbon atoms? 9. It's none. Everywhere single bond. So it's ane. Okay. But at carbon number 1, there's a functional group. Which functional group? It's your acid chloride. Since the carbon of acid chloride is not the part of main chain. Since the carbon of acid chloride is not the part of main chain. Therefore, as the suffix, should I use oil chloride or carbonyl chloride? I'll be using carbonyl chloride. Okay. Similarly, talk about this one. Talk about this one. This is 1, this is 2, this is 3, this is 4, this is 5, this is 6. Right? So what is it going to be? It's going to be cyclo. Is it hexane? No. At carbon number 3, there is pi bond. So it's X3ene. X3ene. At carbon number 1, what do you have? We have got acid chloride. Since the carbon of acid chloride is not the part of main chain, so as the suffix, I'll be using carbonyl chloride. All right. I hope all this is super clear to you. I hope all this is super clear to you. Correct? Now, tell me the name of this one. Tell me the name of this particular compound. Do you see this is carboxylic acid? Which one is this? This is acid chloride. Carboxylic acid is prioritized always. So, for this we are going to use suffix, and for this we are going to use prefix. Okay. Now do the numbering. 1, 2, 3, 4, 5 and 6. So at carbon number 3 there is acid chloride. Right? Acid chloride. And as prefix, what should I use? What should I use? In general, we use haloformyl. So here I'm going to use chloroformyl. Here I'm going to use chloroformyl. Then it's going to be cyclohexane. Then it's going to be cyclohexane. Cyclohexane. At carbon number 1, what do we have? We have got the carboxylic acid. And since the carbon of this carboxylic acid is not the part of the main chain, then as the suffix I'll be using directly as carboxylic acid. Carboxylic acid. Am I clear? Perfect. This particular one you can do on your own. It's a bicyclo compound, right? And I believe this is clear. Now, guys, we are going to talk about one more functional group. What is that? That is your sulfonic acid. And in case of sulfonic acid, you just have to remember two things. What is that? As a suffix, you use sulfonic acid. As a prefix, you use sulfo. Sulfonic acid, sulfo. Yeah? Right? As a suffix, you use sulfonic acid. As prefix, you use sulfo. For example, some examples I'll give. Let's call this as carbon number 1. This is 2. This is 3. So it's going to be what? It's going to be prop. Everywhere single bond. And at carbon number 1, what do we have? SO3H. As suffix, what do we use? As suffix, what do you use? Sulfonic acid. Sulfonic acid. Perfect. Now again, this is 1, this is 2, this is 3, this is 4. What is going to be? It's going to be cyclobutane. Cyclobutane. 1, 2 disulfonic acid. Disulfonic acid. Right? Similarly, this one. 1, 2, this is 3, this is 4, this is 5, this is 6. So again, it's going to be cyclohexane. It's going to be cyclohexane. 1, 3. 1, 3 disulfonic acid. Disulfonic acid. Done? Correct? Okay, let's move on. 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 Talk about these compounds. Talk about these compounds. This is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. Okay. So what is it going to be? At carbon number 4, you have got 2 methyl groups. So it's 4, 4. It's 4, 4 dimethyl. 4, 4 dimethyl. Now it's again cyclohexane. Cyclohexane. Now at carbon number 1, you have got sulfonic acid. Sulfonic acid. Talk about this one. This is carbon number 1, this is 2, this is 3, this is 4, this is 5, and this is 6. At carbon number 2, you have got methyl. At carbon number 2, what do we have? We have got methyl. Then we have got cyclohexane. Cyclohex, right? Is it going to be ane? No. There's a double bond. So it's 1-ene, 1-ene, right? It's going to be 1-ene. Again, at carbon number 1, you have got sulfonic acid. So it's going to be 1 sulfonic acid. 1 sulfonic acid. Correct? Correct, people? सर क्या आप ये जैकेट मुझे दोगे, गिफ्ट करोगे? ठीक है, ले लेना. ले लेना. Done, guys? हाँ चश्मा भी ले लेना तो दैट मुझे दिखे ना कुछ. Okay, what about this particular compound? First of all, it's a bicyclo compound. So write the term bicyclo. Write the term bicyclo. Then do the numbering first of all. Start the numbering from this carbon, 1. Now, bigger size ring, 2, 3, 4, 5, 6. I think we should do the numbering from here. This is 1, 2, 3, 4, 5, 6. So that this gives 7th position. Otherwise, this was getting 8th position. Right? And this is 8. So it's bicyclo. Bicyclo. In the bigger size ring, 1, 2, 3, 4. 4 carbon atoms. Smaller one, 1, 2. 2 carbon atoms. In the middle, there is no carbon atom. So 4, 2, 0. Now there are in total 8 carbon atoms. So it's oct. Everywhere it's single bond. So it's ane. Right? At carbon number 7, what do we have? We have got sulfonic acid. Okay. Perfect. Right, people? Let me take 5 more cases. Talk about this one. It's a spiro compound. It is a spiro compound. Yes, it's a spiro compound. Now, in the spiro compound, from where do we start numbering? The smaller size ring. So call this as carbon number 1, this is 2, this is 3, this is 4. Let's call this as 5, this is 6, this is 7, and this 8. Right? So in total, 8 carbon atoms. So spiro. Smaller size ring contains 1, 2, 3. Larger size contains 1, 2, 3, 4. Right? In total, 8 carbon atoms. So oct. Everywhere single bond. So ane. Now add carbon number 6. What do we have? We have got sulfonic acid. Perfect. Now, here as you can see, carboxylic acid and sulfonic acid. Which one is prioritized? Carboxylic acid always. So for this, I'll be using suffix either as oic acid or carboxylic acid, depending on whether its carbon is the part of main chain or not. And for this, I'll be using prefix. And when we use prefix for this SO3H, what do we use exactly? We use sulfo. We use sulfo. So it is 1, 2, 3, 4, 5, and 6. So it's 4 sulfo. It is 4 sulfo. Now it's cyclohexane. It is cyclohexane. And at carbon number 1, we have got carboxylic acid. Because the carbon, it is carboxylic acid. Because the carbon of this carboxylic acid is not the part of the main chain. Yes? I believe I'm clear till here. Yes? Oh, glad to know that, Ubad. Glad to know that. Amazing. Okay, I believe this is clear, guys. I believe this is clear. Now, talk about esters. Talk about esters. COOR. COOR. Okay, esters. Esters. How do we name these esters? First of all, esters, for esters, we only use suffix. Okay, we only use suffix. They are never used as prefix. So first of all, as suffix, alkyl-O8 or alkyl-carboxylate, depending on whether the carbon of the ester group is included in the main chain or the carbon of the ester group is not included in the main chain. Let me give you the direct example so that you'll understand. Let me give you the direct example so that you'll understand. Asrat Riyaz, sir, I am your student at Srinagar. Great. Amazing. Okay, look at this one, guys. Look at this one, look at this one, look at this one. Okay. For example, you have to name this particular compound. How do you name this particular compound? This is C double bond O, OR. This is C double bond O, OCH3. Perfect. Now do one thing, one simple thing. Between O and CH3, just break it. Just break it. Between O and this, break it. Okay. O and this particular one, break it. Now this particular one which is broken, this particular part which is broken, so write it first. I'll write methyl first. I wrote methyl. I wrote methyl. Here I'm writing ethyl. Here I'm writing ethyl. And here I'm writing cyclohexyl. Cyclohexyl. Now do the numbering here. 1, 2, 3. It's going to be propane. Prop everywhere single bond. Propane. And 1, it's going to be O8. Why? Because the carbon of this is the part of the main chain. And you are going to drop this E because after this E, a vowel sound is starting. Yeah? Perfect. Similarly, look at this one. First of all, you wrote ethyl. First of all, you wrote ethyl. Now it's going to be 1, 2, 3, and 4. It's going to be butane. It's going to be but everywhere single bond. So ane, right? Butane. At 1, it's going to be what? It's going to be O8. Why O8? Because the carbon of this is the part of the main chain. And you can drop this E because after this E, vowel sound is starting. Yeah? Look at this one. It is first of all cyclohexyl. Now this is carbon number 1, this is 2, this is 3, and this is 4. So it's going to be cyclohexyl. First of all, it's going to be but everywhere single bond. So ane. At carbon number 1, it's O8. So I believe all of this you can easily do. I believe all of this you can easily do. Perfect. And in your entire organic chemistry, these are going to be your esters, right? Whose name you have to know. And you can easily do that. You can easily do that. Okay, one more example let me take. Let me take one more example. One more example. First of all, this is O and this. So break it, right? This is O and some its other part. So break it. O and the other part. So break it. Okay. So first of all, this part I'm going to write separate. It's going to be cyclohexyl. Cyclohexyl. Now 1, 2, 3. 3 carbon atoms. So it's going to be prop. Everywhere single bond. So ane. At carbon number 1, it's O8. Perfect. You can drop the other E. Same goes for this one. You can do you can give its IUPAC. You can give its IUPAC as well. Perfect. Here you can just do one thing. The carbon of this particular functional group won't be the part of the main chain. Instead of O8, which suffix you'll use? Tell me quickly. Instead of O8, which suffix do you use? Tell me guys quickly. I told you already. When the carbon of COR is not included in the main chain, then we use carboxylate. I believe all of this is done. So let's talk about one more functional group. What is that? That is N triple bond C, isocyanide, NC. As the suffix you use carbylamine. As suffix you use carbylamine. And as prefix you use isocyanide. Just 2 things you have to remember. As prefix you use carbylamine, and as suffix you use carbylamine, and as prefix you use isocyanide. Okay? So let's exactly get to know how do we name different compounds. So first of all, do remember these 2 things. One is carbylamine, one is isocyano. This is as suffix and this is as prefix. Carbylamine, isocyano. Let's take certain examples. For example, this is the first example. All this is carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6. So first of all, at carbon number 2, you have got methyl. So it's going to be 2-methyl, right? Then it's going to be cyclohexane. So it's going to be cyclohex everywhere, single bond, so it's ane. Now at carbon number 1, what do we have? NC. And as suffix, what do we use? As suffix, what do we use? We use carbylamine. Carbylamine. Okay, we use carbylamine. Talk about the next one. This is carbon number 1, this is 2, this is 3. So first of all, it's going to be cyclopropane. It's going to be cyclopropane, 1, 2, 1, 2. Now it's going to be dicarbylamine. It's going to be dicarbylamine because there are 2, yeah. Okay. Do you think we did some mistake here in this question? Do you think we did some mistake here in this question? Find out the mistake in this question. Find out the mistake quick. Find out the mistake quick. This is CN. This is CN, carbon directly attached. This is NC. This is NC. CN is prioritized over NC. CN is prioritized over NC. So I'll be calling this as carbon number 1. This is carbon number 2. This is carbon number 3. My priority is this one as suffix, and this will be used as prefix. Okay? Tell me what would be the name of this compound now. This I'll be using as suffix. This I'll be using as prefix. Now tell me the name of this compound. Quickly. Quickly, guys. Quickly, I'm waiting for your answers. What do you think? Waiting for your answers. It's going to be 2-isocyano, right? Give it a try, give it a try. Give it a try. Give it a try quick. Quickly, everyone in the chats. Give it a try. No? No? Two isocyano, okay. Then what did you write? Propane or cyclopropane. 2-isocyano, cyclopropane, 1-carbamine. Carbamine. One mistake you have done. You have not mentioned cyclopropane. You have just mentioned propane. See, I told you CN is prioritized. So for this, I'll be using this as suffix. I'll be using suffix for this, and here I'll be using prefix. And when NC is taken as prefix, at that time, what do we use? Isocyano. So it's 2-isocyano. 2-isocyano. Then it's going to be cycloprop, everywhere it's single bond. Cyclopropane. And 1 is going to be carbamine. Right? CN. CN as suffix is carbamine. Okay, what about this one? It's a bicyclo compound. So let's start the numbering from this particular carbon. 1, 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, and 10. So what is it going to be? It's going to be, first of all, bicyclo compound. So it's bicyclo, right? 1, 2, 3, 4. 1, 2, 3, 4. In the middle, there is 0. So it's 4, 4, 0. Total, there are 10 carbon atoms. So it's dec. Everywhere, it's single bond. So it's ane. Now add carbon number 3 and 4. What do we have? You have got 2 isocyanate groups, right? And as suffix, what do we use? As suffix, we use carbylamine. So dicarbylamine. Okay? Okay, guys? Am I clear? I believe I'm clear to everyone. Okay. Now let's move on to few more things. Just a second. Let's move on to few more things. Okay, let's talk about the ketones now. Let's talk about ketones. How do we name ketones? My dear students, in case of ketones, as suffix we use ONE, one, and as prefix you can use oxo or keto. As prefix you can use oxo or keto, and as suffix you can use ONE, one. Okay? Yes? Guys, just give me a second and we shall start. We shall finish it off. Just give me a second. Okay? Just a second. So learned physical chemistry from you in Game of NEET 2.0, cracked NEET 2557. My brother Yasser, 2023. Glad to know that. Congratulations. Guys, I think one mistake we did here. What is the mistake? This is CN here. And as a suffix, what do we use? Do we use carbamine? We use carbamine. Or CN, we use nitrile, right? We use nitrile. Now, do we use nitrile or carbonitrile? Tell me that. Do we use nitrile or carbonitrile? Since carbon of this is not the part of the chain, so it's not neither nitrile, it's going to be carbonitrile. Okay? Now it's clear. Is it clear now? Is it clear now, everyone? Everyone in the chats, quick. Perfect. Let's move on now. So we were basically talking about the ketones now. Huh? So in case of ketones, what suffix do we use? We use ONE at the end. And what prefix do we use? We use either oxo or keto. Let's take certain examples. Let's take certain examples. Okay, let's take certain examples. So first of all, this is your compound. 1, 2, 3, 4, 5, and 6. Okay, right? So it's going to be first of all cyclohexane, 1 ONE. Drop this O. Okay, right, people? Talk about this one. 1, 2, 3, 4, 5, and 6. What is it going to be? It's going to be cyclohexane, 1, 4. Di. As a suffix, what do we use? On. Dione. Clear? Even this one, you have got ketone and your aldehyde. Ketone and aldehyde. Ketone is prioritized over aldehyde. I think I told you the reverse. Aldehyde is prioritized over ketone. And when aldehyde is prioritized over ketone, that means this you are going to take what? This you are going to consider as the suffix. For this you are going to use the prefix. Okay? And therefore it's going to be 3 keto or 3 oxo cyclohexane. 1, since carbon of this is not the part of the main chain, so it's going to be carbaldehyde. Okay. Again, a simple compound. We have discussed all this in very, very depth, very detail. Tell me the answer of this one. Tell me the answer of this particular one. This is your carbon number 1. This is 2. This is 3. This is 4. This is 5. So it's going to be simple. Pent, everywhere single bond. It's going to be 2, 4. It's going to be dione. Right? Dione. Now, it's a spiro compound. And in spiro compound, we start numbering from the smaller sized ring. So 1, 2, 3, 4. Let's call this 5. This is 6. This is 7. And this is 8. So it's going to be, first of all, 1 methyl. It's going to be at carbon number 1, you have got methyl. Then what do we have? Then we have got spiro. Then we have got spiro. In the smaller sized ring, 3 carbon atoms. In the larger sized ring, 1, 2, 3, 4. 4 carbon atoms. Right? So total how many? 8. 8 means oct. Everywhere single bond. So it's ane. At carbon number 6 and 7, you have got ketones. So 6, 7, it's going to be dione. Okay? 6, 7, dione. Yes? Clear to everyone? Now talk about the alcohols. There is one more functional group, alcohol, ROH. ROH. And in case of alcohols, suffix used is all and prefix used is hydroxy. This is something which all of you would be already knowing. All and hydroxy. Suffix, all, prefix, hydroxy. For example, take certain examples. Tell me the names of these. This is going to be cyclohexane all, right? It is going to be cyclohexane 1,2-diol. Okay. This is going to be, for example, 1, 2, 3, 4, 5. So 3, 5 dimethyl cyclohexane 1-all. This is going to be cyclohexane 1, 2, 3. Cyclohex 3-ene 1-all. Correct? Let me give the names. So this is, first of all, this is a simpler one. Cyclohexane 1-all. Drop the C. This is going to be 1, 2, 3, 4, 5, and 6. So it's going to be cyclohexane 1, 2 diol. Diol. This is going to be carbon number 1. This is 2. This is 3. This is 4. This is 5. This is 6. So it's 3, 5. 3, 5 dimethyl. 3, 5 dimethyl. Then it's going to be cyclohexane 1-all. Drop the C. Okay. What about this one? What about this one? This is 1, this is 2, this is 3, this is 4, 5, and 6. So it's going to be cyclo X. It's at carbon number 3, ene. At carbon number 1, it's all. So drop this E because vowel sound is starting after. Yes? Perfectly done. I believe all of these you can easily do. All of these you can easily do, I believe that. Okay? For example, you have got these compounds. This is your carbon number 1, this is 2, this is 3, and this is 4. So it's going to be butane. But everywhere it's single bond. So butane, it's going to be 2, 3, it's going to be diol. 2, 3, it's going to be diol. Right? Talk about this one. It's bicyclo. It's bicyclo. It's going to be, for example, this is your carbon number 1, this is 2, this is 3, this is 4, this is 5, this is 6, 7, 8, 9, and 10. So it's bicyclo 1, 2, 3, 4. So 4, 4, 0, 4, 4, 0. It's going to be dec. Everywhere it's single bond, so it's ane, right? It's going to be 3, 4. It's going to be diol. 3, 4 diol. Okay. Now, among aldehyde and alcohol, which one is prioritized? Aldehyde is prioritized. So this you are going to use as suffix, and this you are going to use as prefix. Okay? You can easily name it now. I believe I'm clear with this. So this is going to be, it's going to be 3-hydroxy, then it's going to be bicyclo. It's going to be 1, 2, 3, 4, 4, 1, 2, 3, 4, 4, 4, 4, 0, 10 carbon atoms, so dec, everywhere single bond, so ane, right? At carbon number 2, there is aldehyde, and carbon of aldehyde is not the part of main chain, so I'm not using al, I'm using carbaldehyde as a suffix. Okay? It's a simple example. You can easily solve it now. I believe so. Now, guys, the last case, what is that? Last scale is cases thiol, SH group, SH functional group. This is our last functional group, SH, thiol. When it comes to your thiols, as suffix you are going to use thiol, and as prefix you are going to use marsepto. Okay? Thiol you are going to use as suffix, marsepto you are going to use as prefix. For example, this is going to be your cyclohexane 1 thiol. Okay, cyclohexane 1 thiol, right? Now, this is alcohol and this is thiol. Which one is prioritized? Alcohol is prioritized. If alcohol is prioritized, so this is 1, this is 2, this is 3, this is 4, this is 5 and 6. So it's going to be, first of all, 3 marsepto. Alcohol is prioritized. So use this as suffix and use this as prefix. So 3 marsepto, then it's going to be cyclohexane, and it's going to be 1 all. Cyclohexane 1 all, right? I hope this is clear. And guys, at the end, this is your priority order. Okay, carboxylic acid is given priority number 1, followed by sulfonic acid, anhydride, ester, acid halide, amide, cyanide, isocyanide, aldehyde, ketone, alcohol, and thiol. This is your priority order. This is your priority order. Perfect. This is your priority order. So, for example, in a compound, if there is, for example, sulfonic acid and let's say cyanide, so this is prioritized. This is used as suffix and this would be used as prefix. Okay. For example, if in a compound you have got 2 functional groups, amide as well as, for example, alcohol. Okay. Amide is given priority. So this is used as suffix and this will be used as prefix. Perfect. So with this, this particular topic, IUPAC nomenclature is done. And I believe from now onwards, if you see any sort of question based on your IUPAC nomenclature, you should be easily in a position to solve each and every question of IUPAC. Okay. And day after tomorrow, I'm going to take one important session for all of you at 8 p.m. to join that particular session. Okay. And I'll let you know the complete organic chemistry schedule as well in maybe tomorrow or day after tomorrow, right? The next chapter, I'll let you know in the Telegram group itself. Okay. Do let me know in the comment section of the video whether you liked the session. Okay. Whether this was beneficial. If this was beneficial, then do let me know in the comment section of this particular video. I would definitely love to see your comments. So take care. God bless you all and bye-bye guys.